Hello everyone and welcome to MB Tutors. I'm Solo and I'll be starting off this paper with you guys. So at paper 2 now, and yeah, let's get right to it. Just a reminder, please don't forget to like and subscribe to our channel, like our videos, and like I always say, spread the word, especially to the grade 11s that will be doing matric next year, or maybe some of you who will be upgrading. You can already see that it didn't really work that well with the exams and you want to still pursue whatever degree that you want to do, and you know you're going to need better marks. So if you're going to upgrade, well, this is your go-to place. Okay, so let us get started and see what question 1 says. All right. A bakery kept a record of the number of loaves of bread a tuck shop ordered daily over the last 18 days. The information is shown in the table below. Okay, so firstly, we're going to have to calculate the mean number of loaves of bread ordered daily. Okay, so let us see here. We're going to need our calculator because we want to save time. We will not be calculating these things manually. So if we're getting the mean, let's get our calculators out. Shift it this side. Okay. So, we're going to enter the data. So when you enter the data, you're going to go to mode, setup, and you're going to go to stat. Okay, so 3 is stat, and then we're going to do 1 minus variance. Okay, if you had a data set of x and y, you were going to go to a plus bx. But what we're interested in is 1 minus var. So that's that. So we only have one data set. Okay, so we're going to enter. Hope you guys can see. Okay, so we have 10 and then equal 11, 13. They already put it for us in order. So that's nice. 13, 14. We have 2 14s, and then 15, 16, 18. Okay, 18 again, and we should make sure when we're done we have 18 data. That makes sense. Yeah, 19, 20, 21, and then 35, another 35, okay, 37, 40, 41, okay, 18, yes. Okay, so once you put your data, you can just say AC. All right, and if you want the mean, again, we go to shift. This time you come here, stat. So shift 1. The type of data, well, you can just go there if you want to check if your data is there and it's proper. Sorry, that's actually number 2, data, if you want to check your data. And then we're going to go to VAR, right, where we have everything. N just says, do you have 18 data sets? I don't want to say data sets, but there are 18 values for your data. And then 2 is what we're interested in, the mean. Okay, so the mean that we have there is 22. Okay, so 11.1.2. Now we need the standard deviation of the data. Go back to our calculator, AC, then shift. Because the data is still there, we don't have to enter it again over and over. So we go to VAR, and there, number 3, that will give us the standard deviation. So the standard deviation, just gonna put it like that. Okay, now I forgot the value. 10,17. Okay, 10,17, and then 11.1.3. So it says the number of days on which the number of loaves of bread ordered was more than 1 standard deviation above the mean. What exactly is standard deviation? Well, basically, when you have your mean, just gonna put there, that's your mean. Okay, the standard deviation is basically when you look at your average, the other values how do they compare with your average? Are they far from your average? Are they close to your average? So when we go to this side, let's say we're going to have 1 standard deviation, then you can have 2 standard deviation. If you go this way, you're going to have minus 1 standard deviation and so forth. So we just want to see how far our data set is it from the mean. Okay, the closer it is to the mean, you know that you're getting more of a accurate data set, especially if you're taking, I don't know, you're doing an experiment and you want to measure the temperature of something and you keep getting like values that are close to each other. Okay, so your standard deviation will be much closer to the mean. But if your data set is like all over the show, okay, you're gonna get your mean, okay, and then you get data set there and some of it here and some of it far, like it's just all over the place. And if you have a data set like that, guys, and you're doing research, people won't trust your results and your whole research will be like flawed. So you have to start again. Okay, so the closer you are to the mean with your data set, the better. You don't want too many just random data sets, okay, or data numbers that you have. You want something that is closer to being precise, okay, precision, okay. So yeah, anyway, they only want 1 standard deviation. So it says more than 1 standard. If they said less than 1 standard, we would be looking here. So what is our standard deviation that we got? We got a standard deviation of 10,17. Okay, so okay, our mean there was 22. Okay, so we're gonna add 1 times the standard deviation. Okay, so ultimately that answer, let me just take the calculator to the other side. Okay, so we have 22. Let me see if it recorded that answer. Yes, it did. So I can say answer plus 22, and then we get 32,17. Okay, and that is that. Oh, we're not done. They said the number of days, the number of days on which the number of loaves of bread ordered was more than. So once you have your 32, we're going to have to go to the data set and look for values that are higher or closer to 32. Okay, so 32 and higher. So we see from 21 we get 35. So 35, 35, 37, 40, 41. So that's basically 5 days. Okay, and that is the final answer. Sometimes you can get so excited about calculating something that you forget what the actual question was. Okay, I'm guilty of that. All right, so 5 days. That is our answer. All right, and then 11.2. Sorry. Oh my goodness. I've been saying 11. I'm already at question 11. What is wrong with me? Okay, it's actually 1, guys. Yo, I'm in a hurry. Okay, 1.1.1. And then we go over to 1.2. All right, now it says the tuck shop owner was not able to sell all the loaves of bread delivered daily. He calculated the mean number of loaves sold over the 18 days to be 20. So we calculated 22, right? But when he actually, that was his prediction, because what he did maybe the previous week, the last 18 days, he thought maybe it will replicate itself, but it didn't. So now his mean is 20. Now it says calculate the number of loaves of bread which were not sold over the 18 days. Okay, so remember guys, when you do your mean calculation, you're actually taking all your data sets. So it'll be 10 plus 11 plus 13 plus all of them until we get to 41, right? And all of that we divide by 18 because that is the number of values that we had over the 18 days. Okay, and using that, we calculated previously that our mean was 22, but now it says they didn't actually sell all of them like he had predicted, but the mean that he got was 20 rather. Okay, so now calculate the number of loaves. So all of this will really be the number of loaves that were sold. Okay, so the mean was 20 instead of 22, and these are the number of loaves. Okay, and that will be over the 18 days. So now we want to see what were the number of loaves. Okay, so 20 times 18. Okay, but what he had predicted, or the orders, yeah, actually this is what the shop ordered, but what was actually sold, that's a different story. Okay, so this is the number of loaves sold, but what were the number of loaves ordered? Yeah, actually, yes. I should have just put it like that in the first place. That's what they ordered, and we calculated that the mean was 22 there. But what was actually sold, that's a different story. Okay, so let's calculate. So 20 times 18, that'll give you 360. Okay, that is the amount that was sold. But now, what was the amount that was ordered? It is actually 396. Okay, so now the number of loaves that were not sold, what would that be? So we're going to take the number of loaves ordered and subtract by the number of loaves that were sold, and that will give us bread not sold. Okay, so I'm going to say bread not sold. Okay, and that value will be okay, 36 loaves. Okay, and that normally happens, guys. So you would have maybe Nestle supplies different shops like Checkers and ShopRite and whatever with tins of Nespray. Okay, and they order, let's say, 300 tins of Nespray, but what was actually sold was just probably 240, and then the 60 they would take back to Nestle. Okay, especially if it reached the expiration date. Okay, so that's what I've learned. I've seen that. My father used to work at Nestle, so they would come back, and then especially with chocolates, then we would get a lot of chocolates, but they were close to the expiration date, so we'd have to eat the chocolates very quickly. So what you order doesn't mean people are gonna buy all of it. Okay, so this is where you use this kind of mathematics. If you want to know how to practically use it, this is it. Stats. Okay, so that was 1.2, and then we get to 1.3. Yeah, so one of the two box and whisker diagrams drawn below represents the data given in the table above. Okay, so 1.3.1, it asks which one of the two box and whisker diagrams drawn above correctly represents the data. Okay, and write down a reason for your answer. Okay, so what is a box and whisker diagram? Basically, what you put there, firstly, is your minimum value. Okay, then you put Q1, Q2, Q3, and then your max. So your whiskers are the minimum and the maximum. Okay, and from our data set, we can see that the minimum is 10, all right, and the maximum is 41. Okay, so what is Q1, what is Q2? So that's the first quartile. The second quartile, which is like your median, your middle value. Then you get the third quartile, okay, and then you get your max. So if we look at our data set, we have 18 values here. So the median, the middle one, okay, if you have 18, it'll be the 18 there. If I just zoom in, our middle value, because we have an even data set, okay, If it was uneven, if it was odd, it would be easy to just pick out a number. But because it's even, you're going to take your 8th value and your 9th value and divide it by 2. Okay? So that you can get the average of that. Okay? So the number between 18 and 19, that will be 18 and a half. Okay? And then the Q1 is half of half. So your half was 9, right? We have 18 days. So yeah, 6, yeah. So you have 9 right now. If you take half of 9, we're going to go all the way to 4. So our 4th data set is 14 and our 5th one. So you take 14 plus 14 divide by 2. But that will just give you 14. And even here as well, you take your 4th, which is 35, and your 5th, which is 35. So we know that Q is actually 35. Okay, so this is what we're expecting on our box and whisker diagram. We're expecting 10. Okay, let's have a look. We're expecting 10, so both of them, 10 and 10. And then we're expecting 41 at the end. So we have 41 and 41. Great. And now we are expecting our Q1 to be 14. Okay, so we can see here already with the graph A is already wrong. It's not 18. 14 is our Q1. Okay, and our Q3 is 35. So graph B is winning. And then our median is 18 and a half. Okay, so graph B is definitely the winner here. Okay, it represents the data correctly. And now what they were asking here is write down a reason for your answer. Okay, so graph B, because our Q1 is 14 and not 18, and also our median is 18 and a half and not 30. Okay, that is why we chose it. Other values are the same, but those two, Q1 and Q2, they don't match. All right, and then 1.3.2, describe the skewness of the data. All right, so how would you describe the skewness of the data? Well, you can look at the box and whisker diagram, and you can also, you could also describe, you could look at the mean and the median. Okay, so let's start with that. If your mean, okay, or rather, let me just put X bar. If your mean is equal to your median, okay, that means your data is symmetrical. Okay, on your box and whisker diagram, the median would cut the box in half. Okay, your data would look like this, symmetrical. All right, if your mean is bigger than your median, then your data set is skewed to the right. Okay, meaning it would look something like that. No, I'm not drawing it right. That is skewed to the left. So skewed to the right, meaning you have your data set here, and then it's skewed to the right. Okay. And then if your mean is smaller than your median, then your data set is skewed to the left. Okay, so the longer portion of it is to the left and that. Okay, so looking at our diagram, well, we already know, I mean, our mean was what? It was 22 and our median 18 and a half. Okay, so definitely if you were to describe the skewness of the data, we would say it's skewed right. And you can also see the bigger portion on your box. Okay, if you look at your box and whisker diagram, the bigger portion is to the right. So that's another way of viewing it, that, okay, it's skewed to the right because the bigger portion in the box is on the right. Okay, but otherwise, you could just compare your mean and your median, and then you can see whether it is skewed left or right. Okay, and that is it for question 1. I will see you guys in another question. I don't know which one, but yeah. All right, thanks for tuning in.
Well, welcome to MV Tutors. My name is Fikakahle Manana and I'll be your tutor today. Well, we are doing the November 2021 final examination for mathematics. This is now paper 2 and I'll be doing question 2 with you. So if this is what you're looking for, then stick around. I'll teach you how to do this question and I'll explain it in a more digestible way to you. Now, if you're looking for a tutor, we are available. Just contact us on www.mvtutors.co.za or WhatsApp us on 076-312-1107. And before you do, please make sure that you speak to your parent or your guardian, get them involved in the process, because remember, at the end of the day, they are the ones that are paying, so they need to be involved. Well, other than that, let's get right into the question. So it says here, a farm store sells milk in 5-liter containers to the local community. Now the price varies according to the availability of milk at the farm store. The price of milk in rands per 5-liter container and the number of 5-liter containers of milk sold are recorded in the table below. Okay, so here we go. There's a table. It's a table with two variables, x and y. Okay, so the first thing they're saying is that on the grid provided in the answer book, draw the scatter plot to represent the data. So what I'm gonna do now is I'm gonna change my background here and then I'll start plotting. Okay, there we go. So I have drawn it over there. So what we're gonna do is that we're gonna take these variables and plot them. So on the x-axis we have the price of milk in rands per 5-liter container, and on the y-axis we have the number of 5-liter containers of milk sold. Okay, so on the x, let's go look for 26. We look for 26. It's somewhere there. And then on the y, we look for 48. So we go 26 and then we go up 48. It's going to be somewhere over there. Okay, there's our point. And then the next one is 32. 32 is somewhere there. And 30. Okay, 30 is 30. It's there. So 32 and 30. Point is somewhere there. The next one is 36. 36 will be somewhere there. And we go up 26. So 26 is going to be somewhere there. The next one is 28. So 28 somewhere there. And we go up 44. 44 is somewhere there. Cool. And then the next one is 40. Okay, there's 40 there. And then we go up 23. 23 is somewhere there. Okay. And then the next one is 33. 33 is somewhere there. And 32, go up 32. So 32 is somewhere. So that's 30, so 32 is somewhere up there. Okay, and then the next one, 29 and 39. So 29 somewhere there, 39, 39 is somewhere there. Cool. And then the next one is 27, which is somewhere there. And we go up 42, which is gonna be somewhere up there. The next one is 30 and 33. 30 and we go up 33. It's going to be somewhere up there. Okay, so that's our scatter plot, just like that. We don't need to draw a line, but we can pretty much see what's happening already. The more we increase on the x, we decrease on the y. Okay, that's it. Now the next question says determine the equation of the least squares regression line for the data. Okay, I'm just gonna continue with this background. I can always change it to white. Actually, let's do that because I prefer white myself. Let's format the background. Okay, let's go back to white. Good. Okay, so this is now question 2.2. 2.2. All right, for this one we need a calculator. Let's get a calculator. Let's put it this side, right there. Okay, so what you have to do then is that in the calculator, first we go mode, and then we're looking for stat because we're doing stats there. Now there are two variables here, so we're gonna go for number 2. So you go number 2, x and y. So x and y, as you can see there, x will put these values. Let's go ahead, press 26 and then go equal. The next one is 32 and then equal, and then 36 equal, and then 28 equal, and then 40 equal, and then 33 equal, and then 29 equal. Now I need to see all the values. So the next one, we ended at 29, we go 34 equal, and then 27 equal, and then 30 equal, 10 values, and then we're done with the top row. So what you're gonna do is press down, go down once, it'll take you back up, and then go to the side, put our y values. So we start with 48 equals, and then we go 30 equals, and then we go 26 equals, and then we go 44 equals, and then we go 23 equals, and then we go 32 equals, and then we go 39 equals, and then we go 29 equals, and then we go 42 equal, and then 33, which is the last value, equal. All right, 10 for 10. Now what we do is just press AC. That's it. We're still on stat mode, so we can go shift, and then you see there's a stat there on number 1, so you press that number 1. Now what are we looking for? We're looking for the regression line. Okay, so there it is, number 5, so we'll press number 5. Okay, now we got values of a and b. So what I want to do, let me just put this side. Our equation was y is equals to a plus bx. Okay, so for the value of a, we're going to press number 1, and then we press equal, and then it gives us 90.478. okay, plus, let's go look for b. So you can go clear again and go shift, go back to stat, which is number 1, go back to regression, which is number 5, and then we're looking for the value of b, which is number 2. So we press 2 and then we press equal. So we have that it's minus 1.774. okay, and x outside. So my equation line then is y is equals to, I'll start with the x because that's how we do it, minus 1.774x plus 90.478. Okay, that's it. All right, now just to go back to your normal mode, you go mode and you press 1 comp, and then you're back to the normal. All right, let's go for the next question then. We're done with 2.2. 2.3, if the farmer sells a 5-liter container of milk for 38, predict the number of 5-liter containers of milk he will sell. Okay, so what is, remember the price is the x, you see, that's the x row. So even here the price is represented by x, and then the number of containers is represented by y. So we'll take this very same equation. So now this is 2.3, which is y is equals to that, and then we will actually substitute 1.774. where there's an x, we'll put 38. Okay, plus 90.478. Let's put that in a calculator. So we're gonna go negative 1.774 times 38 plus 90.478. Then the answer is 23. Okay, 23. Okay, so this is the number of containers. That's our final answer, 23. Cool. Let's go to the next question. 2.4 says, refer to the correlation between the price of 5-liter containers of milk and the number of 5-liter containers of milk sold, and comment on the accuracy of the answer of question 2.3. Okay, so what we're gonna do then, we're now on 2.4. Okay, first of all, let's go to the correlation. To get the correlation, we have to look at the graph. What's happening? What's the correlation? The correlation is such that as the price increases, as we increase the price, the number of containers of milk sold decreases. As you can see, they decrease as we move towards the right. The vertical moves down. So we're gonna write that in words. So we're gonna say as the price increases, get more space, the number of containers sold decreases. That is the correlation. And then they say comment on the accuracy of your answer in question. Okay, so x is 38 and y is 23. That's the answer. Let's go see where it lies on the scatter. So 38 somewhere there, and 23, let's see where is 23. So 38 would be somewhere there, and 23 would be somewhere there. So our point is somewhere there, which actually, as you can see, it falls right into the trend. Okay, so our answer is in line with the trend. Okay, so our answer is in line with the trend. The trend being that as the price increases, number of containers decreases. That's it. Well, that's all that I've got for you today. If there's something you didn't understand and you need extra help, you know what to do already. We will be available. And I hope though that you did understand. And well, it's goodbye from me, and we appreciate you. Well, welcome to MV Tutors. My name is Fikakahle Manana, and I'm gonna be your tutor today. Okay, so we are still doing the 2021 November final examination metrics. So this is now question number 3 that we will be tackling right over here, as you can see it on the side here. Now I just want to read what it says, but before I do that, just part of my welcome, I just want to let you know that we are available to tutor you whenever you need. Just contact us through our email or our WhatsApp line. So our email is www.mvtutors.co.za. Our WhatsApp line is 076 312 1107. Okay, so let's get right into it. It says here in the diagram, A is -2 and 10, B is KK, so it's the same value there, and C is 4 and -2 are the vertices of triangle ABC. Line BC is produced to H. Line BC is produced to H. That means it's a straight line. Okay. Sorry, there's a fly here disturbing me. Okay, and then what else happens? And cuts the x-axis at 12 at E to 12 and 0. Okay, there we go. AB and AC intersect the x-axis at F and G respectively. What did they say? AB? Oh, there, F and G, I see them. The angle of inclination of AB is 81. Okay, there it is. Right. Now, what is the question? The question is, calculate the gradient of BE. Where's E? There we go. So BE is this straight line, and to calculate a gradient we need two values. So we're going to take the value of C there and E there. It's still the same line, right? Okay, so I'm gonna say so C is given by 4. Okay, I just want my pen to be a little bit thicker than this. Let's try that one. So C is going to be it's not equals to, it's the coordinate 4 and -2, and then E is the coordinate 12 and 0. So what I like to do is just put X there and Y there, and then I know that my gradient then will be given by YC minus YE divided by XC minus XE. So that's gonna be YC. I just come here, I got two values of Y, so I want the C1, so it's -2, and then minus the YE is 0 divided by XC. Got two values of X there, the C1 is 4 minus E1 is 12. Okay, so here I've got minus 2 over 4 minus 12. Really, that's like 4 minus 12. I think that's 8. So then that means my gradient is minus 1 over 4. Okay, so this is the gradient of BE. Remember, they asked us gradient of BE. Okay, so this is for 3.1.1. Now, they want the gradient 3.1.2. They want the gradient of AB. Oh, there we go. AB is that one. So what do we have here? Should be able to use what you have to solve what you don't have. Okay, let's give ourselves some space, and then let's do 3 point. Let's make it thicker. This is now 3.1.2. They want the gradient of BE of BA. So the gradient is also given by 10 theta. Okay, so I'm just simply gonna say 10 theta is just simply gonna be 81.87. Cool. Now let's get a calculator for that. There we go. So we want 10. Where's 10? There it is. 10 of 81.87. Close that bracket. It's equals to 7. Okay, so that's the gradient of BA. That's it. That's what they wanted to say. Or AB. Okay, let me write it exactly like they did. They said AB, so I'm gonna say AB too. Cool. All right. Let's see the next question. Determine the equation of BE in the form y is equals to mx plus c. The equation of BE. So where's BE? Oh, BE is this one that we just solved. So we already have the gradient. Now we just need one point that passes through it to solve the other one. So an easy one, I can take anyone. Let's go for C though. Let's get some space there. Let's make it a bit thicker. Cool. So this is now question 3.2. Okay, so for 3.2, they want it in this form, right? Y is equals to mx plus c, but we've already solved for m and we found it to be minus 1 over 4x plus c. Now to solve the value of c, we need to take either 4 and negative 2 or 12 and 0 just to solve for that. Let's take C. Okay, so let's take 4 and negative 2. Cool. So that, and then I like to put this on top so that I'll know where there's a y, because under exam stress it's very easy to confuse this and they end up putting a 4 where it's supposed to be a negative 2. So negative 1 over 4 times x is 4, right? Plus c. But then these cancel each other, so I really have negative 1 here. And then if I bring this negative 1 to the other side, to get rid of it, it becomes just hold on a second. Hold on. Let me just go confirm that my gradient of BE is negative. 1 over 4. It doesn't look like it should be. It should be positive, because we got a negative here, and 4 minus 12 is a negative 8, and that should be a negative 4. So then the gradient of BE is really 1 over 4, and it's positive. Okay, so that helps me because now I know that this gradient is positive here, so that's a positive 1. So when I take this positive 1 to the other side, becomes negative, so then I'll have minus 2 minus 1, which is minus 3, as a value of C, and then that completes this equation. So M is 1 over 4, it's positive, X remains, and then C is minus 3. There we go. Okay, now don't be afraid to make mistakes, okay, because sometimes we learn from mistakes. So it's good that I made a mistake, but what you should do with your mistake is that you should reevaluate and try again. It's very important to reevaluate and try again. Don't just leave wrong answers wrong, or don't just leave concepts ununderstood. As soon as you get something wrong, try by all means to see where you went wrong, seek help, and then correct yourself before it's too late. Okay, let's do question 3.3 now. So let's say the first one, calculate the coordinate of B where K is negative. Okay, so this B, K is negative, it's the same value on both sides. Okay, so what can we do here? What we can see is that this point B is where this graph BC or BE that we have solved here, which is this one, is where it meets the graph of AB. Okay, so we already have this formula for this graph BE. Now we need for AB, we need to solve for AB, so let's do that. Okay, so this is now going to be question 3.3.1. Okay, let's start with formula for BE. Do we have the gradient? So it should be in this form: y is equals to mx plus c. I think we did solve it, the gradient of BA, because I remember we put this in a calculator. Let's see, there it is, it's 7. Okay, so then that means we have y is equals to 7 x plus c. Now we need a point where this graph passes. We only have one point, it's minus 2 and 10. I'll put my x there, I'll put my y there. So where there's a y, I'll put a 10. Where there's a x, I'll put a negative 2 plus c. And then what's this? It's negative 14. So if I bring it this side, c will be 24. Okay, because this is going to be negative, bring it this side, it's a positive 14 plus 10, it's 24. So now that means that I've got two graphs. Okay, let me just complete this one. It's going to be y, m is 24, x plus, no man, that's a mistake, it's not 24, it's 7x plus 24. Cool. Now the other one, this is my, let's call this one equation number 1. Equation number 2 then will be this one that we solved above here, which is 1 over 4x minus 3. Okay, that's equation number 2. Cool. Right, so what I want to do now is just do simultaneous equations, equate the two graphs, and then solve for x. So all I'm going to do is that I'm going to put a line there, and I'm going to subtract them. Okay, let me just put, just to show that I'm subtracting this in a bracket from the top. So this is really equation 1 minus equation number 2. That's all we're doing. Okay, so y minus y, that's gonna be 0 equals to 7 minus a quarter. Oh, I need a calculator for that. It's 7 minus a quarter, 1 over 4, and I get 27 over 4. Okay, it's 27 over 4 x, and then what's 24 minus 3? 24 plus 3, that's 4 plus 3 is 7, so that's it's gonna be a positive 27. Okay, now I need to solve for x, so I take the 27 this side, just doing some mathematical gymnastics, and then take the 4, get rid of the 4 by multiplying by 4, get rid of the 27 by dividing by 27. So these will cancel, and then therefore my x value is gonna be equals to 4. Now what can we do with that 4? Okay, so that means k is actually 4, and then that point B, did I say solve k or solve B, coordinate of B? Okay, so they want the coordinate of B, so that's gonna be 4 and 4. Hold on, why are they positive? They should be negative because they are on the negative side. So I missed something. Yes, I did miss something. This 27 is negative when I take it to the other side. So then it's negative 4 and negative 4. Cool. Because when I take this to the other side, it changes sign, remember? Good. So B is negative 4 and negative 4. Okay. Now the next question, the size of A. Where is A? Oh, they want the angle of A. Okay, cool. We can do that. That we can jam. All right, so A, what can we notice here? Okay, we need this angle over here. So to get that angle, we're gonna say we need the gradient first. So this is now question 3.3.2. Okay, so we've got A, and it's negative 2 and 10. And then we've got C, which is 4 and negative 2. Now the gradient is going to be YA minus YC divided by XA minus XC. YA, let me just put these so I take the guesswork out of it. So YA, it's Y, got two values of Y. I want the A1, which is 10 minus YC is minus 2, so I'll put it in a bracket, divided by XA. XA is minus 2 minus XC is 4. So what do we have here? 10 plus 2, that's going to be 12. divided by minus 2 minus 4, that's minus 6. So 12 minus 6, my final answer is going to be negative 2. So I have a gradient, and my gradient is negative 2, but what I'm interested in is the angle, okay, that gradient makes. So tan theta. So what I have here is the negative 2 comes there under the gradient, tan theta, and what I want to solve is theta. So theta is just gonna be arctan, inverse of tan, and let's put negative 2 there. Let's see what happens. Okay, let's get our calculator. Arctan is shift tan, and let's put the negative 2. Okay, and it gives us negative 63.43. They didn't say anything about decimal points, so we'll use the common 2. That's fine, because this one is also in 2. So now what do we have here? This is what we have. We have a triangle, okay? We have a triangle like that. And from that triangle, we know that that angle there, okay, let me just write it in, is 81.87. And then this one here, this one is 63.43. And then the one we are looking for is this angle A. You can see it now. So basically we're just gonna do let's give us more space. We're basically going to do the sum of the triangle angles. So we know that angle A plus 81.87 plus 63.43 is equals to 180, and the reason is because it's angles in a triangle. Angles in triangle. Okay, so then we can solve for A, the angle of A. Okay, angles, you must always put this thing, this hat, to show that it's actually an angle. Okay, so it's gonna be 180 minus 81.87 minus 63.43, and then we get 34.7 degrees. Okay, so that's the angle of A. Cool. Let's see the next question now. Okay, size of A, we got it. Now let's say the coordinates of the point of intersection of the diagonals of a parallelogram ACES, where S is a point in the first quadrant. Okay, we need to visualize what's happening here, and we need to read it slowly. First of all, ACES, so S is there in the first quadrant. What I want to do is just, let me redraw it to the side. So this is now 3.3.3. So it's A, C, E, S in the first quadrant, and then a join. And I've been told it's a parallelogram. Okay, parallelogram, you know, this line is parallel that one, and then this one is parallel that one. Okay, so that's point A. This is point C, that's E, and then that's the S they're talking about, S. Now let's read the question very slowly. Coordinates, okay, we're looking for coordinates of the point of intersection of the diagonals of the parallelogram. So they want the point of intersection of the diagonal. This means I need to draw diagonals. So diagonals are from corner to corner. Okay, like that, and then just like that. And what do we know about diagonals? They bisect each other. Okay, so that one is going to be equals to that, and that's going to be equals to that. Now they want the point of intersection of the diagonal. So what we are looking for is this point right here in the middle. Okay, now what do we have? We have minus 2 and 10. We have C as 4 and minus 2, and then we have the point of E, which is actually 12 and 0. Okay, so we're looking for this point in the middle. We can use the midpoint theorem to calculate this midpoint. That's the one they are looking for. Okay, all right, so let's just put that right there and then continue with our calculation. So we know that AC is the midpoint. The midpoint is between A and C. Okay, so it's gonna be XA plus, not A and C, man, A and E, plus AE divided by 2. That's the coordinate, and then this side is gonna be YA plus YE, and it's gonna be over 2 as well. So what's XA? XA is minus 2 plus XE. XE is 12 divided by 2. That's what we have this side. This side YA, which is 10, plus YE is 0 divided by 2. And then what is our coordinates then? Our coordinates, minus 2 plus 12 is 10. 10 divided by 2 is 5. 10 plus 0 is 10. 10 divided by 2 is 5. So that is our midpoint. There we go. Okay, so let's do question 3.4 now. And we'll do it in blue. 3.4. Okay, so it says another point T where P is positive is plotted such that ET is equals to BE. So ET is somewhere, but BE is there, and then both equals to 4 square root of 17. Okay, so let me just demonstrate this like that. So that's gonna be BE, and that's gonna be, I'll make that T. So that's gonna be E, that's gonna be T, and that's gonna be B. Okay, so it's that B. Right, now they say and okay, the distance is 4 square root of 17, right? Even here, 4 square root of 17. Okay, all right, such that, okay, calculate the coordinates of T. Okay, so coordinates of T. All right, so what we can do here then is actually to use the distance formula. So the TE distance is equals to square root of x, let me say xt minus xe squared plus yt minus ye squared, and all of this is under a square root, right? So te we told is 4 square root of 17. That's equals to xt. Okay, so let me just write these points. E is given by 12 and 0, and then t is given by, they told us here, p and p. So xt really is just p minus xe, as you can see, is 12. All of this is squared, plus yt is p again, minus ye is 0. Cool, and that's squared. Now we have to do some mathematical gymnastics, okay, under the square root. P minus 12. I always do this because, you know what, I don't want to miss a beat. Don't want to make a mistake. So open two brackets, and then p times p is p squared. P times minus 12 is minus 12p. 12 minus 12p again, and then 12 times 12 is 144 plus p squared, and all of this is still under a square root. Let's got more space to continue with our gymnastics. So I got p plus p there, which gives me a square root of 2p squared, and then minus 12 is minus 24p plus 144, and all of this still under square root. Okay, so what I want to do now is get rid of this square root sign, so I'm just gonna square both sides. It's gonna be squared, and then what's that gonna give me? Should I change this to a number? Let's just put it in a calculator, you know. 4 square root of 17, close the bracket, square. No, close the wrong bracket, so I should go to the side first, close the bracket, and then square it. Good. So I get 272 is equals to 2p squared minus 24p plus 144, and then I want to bring this number that side, 2p squared minus 24p. I want to say 144 minus 272. I get minus 128. Okay, so we gotta solve for p. Let's just put it straight into a quadratic equation. Okay, so p is equals to minus b plus or minus b squared minus 4ac. In grade 12 you should know the quadratic formula by head. So that's a, that's b, and then that's c. Okay, I like doing that as well, so that my readings are just accurate. So minus, and a b is minus 24 plus or minus the square root of b squared. B is 24 squared. Remember, it doesn't matter whether it's negative or positive here. Whatever number you square, it's always gonna give you a positive number. Minus 4a. What's a? A is 2. C is negative. I need more space. C is negative 128. And all of this is divided by 2 times a, which is 2. Okay, let's put it in the calculator now. So we got our, let me put that fraction, 24. It's positive. Let's start with a plus. All of this is under a square root. Plus the square root of 24 squared minus 4 times 2 times a negative 128. And I'll come downstairs and I'll put 2 times 2. Okay, 16 is my first answer, and it's a positive 16, so P is 16, or P, now what I gotta do is go back there, okay, and then change that plus, delete that plus and put a minus, and then P is minus 4. Okay, we can only have one answer here, so let's see what they're saying. Calculate the coordinates of t. What did they tell us about t? PP must be positive, see, greater than 0. So P cannot be equals to negative 4, therefore P is equals to 16. Okay. Good. So they said calculate the coordinates of t. So then t, remember, coordinates come in x and y. So it's 16 and 16. That's it. Cool. Then determine the equation. We are now moving on to 3.4.2a. Okay, determine the equation of the circle with a center at E passing through B and T in the form. Okay, so let's draw a circle first. Let's say that we can visualize this thing. So we've got a circle, and then we're told that center is at E. So there we've got a center at E, and then passing through B and T. Okay, so from E to B, we know that it is the units of it's 4 and the square root of 17. Okay, we're told there. And then the coordinate of E is actually 12 and 0. That's all we need. That's all we need, really, because even if we use T is still a radius. It's still gonna give us 4 square root of 17. So they want it in the form x minus a squared plus y minus b squared equals to r squared. Okay, that's cool. So x stays x minus a is this one, xy. A is 12 from the center plus y, b is that y, so it's 0, is equals to r is the radius, and it's squared, which is 4 square root of 17 squared. So I'll leave my answer like this. What's going on there? Did not ask you to do a circle. X minus 12 squared plus y squared is equals to 4 square root of 17 squared. Well, you can simplify this 4 square root of 17 if you want, but it's not really necessary. It's still r. Let's do part B now. So we've got B over there. Cool. Then it says the tangent to the circle at point B. Okay, so the tangent would be over there. So that's the part, that's point B. All right, so what do we know? We need first of all, the tangent is given, it's a line mx plus c. So we need to solve for m first, which is the gradient. And remember, these are perpendicular. The tangent is always perpendicular to the radius. So we know the gradient of BE to be a quarter. We solved it. Somewhere there when we were solving in part 3.2. So if you have gradient 1 and times gradient 2, they are equals to minus 1 if they are perpendicular. So gradient 1, I'm gonna make that the gradient of BE, and it's a quarter, times the gradient that we are looking for is equals to minus 1. Okay, so that means our gradient then is equals to minus 4, because to get rid of this 4, multiply both sides. All right, now we have the gradient, so let's just plug it in. It's minus 4x plus c. To solve c, we need a point that this line is passing. Fortunately, we know b is minus 4 and minus 4. Remember, we solved it. That's gonna be x and that's gonna be y. So where there's a y, I put minus 4. Minus 4. Where there's a x, I put minus 4 as well, plus c. Minus 4. 4 times 4, this is a positive 16 plus c. So what is our c then? If I take this to the other side, it becomes negative, so that's negative 20. It's equals to c. Okay, so we can complete our tangent formula. It's y is equals to m is minus 4x and then minus 20 for c. That is our tangent formula. Well, that's it from me. That's it from this question. If you need any help or you didn't understand anything we did together today and you need extra explanation, you know what to do already. Email us, visit our website, WhatsApp us. You will find all of that contact information under the description of this video. Otherwise, like and subscribe to this channel. We appreciate you. Well, welcome to MV Tutors. My name is Figure and I'll be your tutor. We are still doing the November 2021 final examination memo. So we are now on question number 4. Let's get right into it. So in the diagram, the circle centered at N, okay, and there it is there, center, passes through A, as A, there it is, and C. Cool. Now B is given as the coordinate C, D, and E. B, C, D, and E are joined to form a parallelogram. Okay, I see it. Parallel lines, such that BE is parallel to the x-axis. So PE is parallel to the x-axis. That means CD is also parallel to the x-axis. CD is a tangent to the circle at C, and CD is 6 units. Okay, I see it's given. Cool. Now what's the first question? The first question is, write down the length of the radius of the circle. So that's 4.1. 4.1, they want the length of the radius. So the radius, let's just come and look at here. What do we know? Okay, so even though it doesn't look like it here in the circle, but these numbers are actually on the same path. So it's like this. Okay, you have a circle, and then you have the center N there, and then you have A right under it. That's A, and then C right on top of it. So all of them share -1 on their coordinates, and then the difference, that height then, and N is 3 and here is -1. So to solve our radius, we're just gonna say 3 minus -1, and that's gonna give us 4 units. Okay, so the radius is just simply 4 units. Okay, let's check out the next question. 4.2.1, calculate the coordinates of C. Oh, right, C is just on top. Now I want you to see something. So okay, it's 4.2.1. they want the coordinates of C. So first of all, C, remember the x is also going to be -1 since they're all in the same line. And then the y, remember we just solved that it's 4 units. The radius is 4 units. So the same radius that is here is the same radius that's there as well. So we just need to add 4 to 3, and that gives us a 7. That's it. Okay, 4.2.2, the coordinates of D. Now let's find D. D is over there. Okay, so what's happening here? Remember, this line is parallel to the x-axis. So this is 4.2.2. we're looking for D now. So here we have a parallel line to the x-axis. That's where D is, right? So we know that actually if you look at the y is the same. It's still 7 units because it's parallel to the x-axis, right? So it's 7 units on the y. It's the same y. The difference then is on the x. Now they've told us that this is 6 units. So from C, really what we should do then is say -1. From -1 plus 6. -1 plus 6 units, that gives us a 5. So then D is simply just 5 and 7. Okay, let's go check the next question. Area of BCD. Okay, so let's check this out clearly now. Well, 4.2.3. So BCD, okay, so check this out. You've got, let me just draw the whole parallelogram. It's just basically like that. So what do we have? That's B there, that's C, that's D, and that's E. And they said B, C, D, they want the area. So it's half of that. So we really need to just solve this triangle. Now you know that the area of a triangle is half base times height. Fortunately, we have the base, it's 6 units we were given, so that's gonna be times 6 times, and then the height, it's a perpendicular height, it's not just any height, so it's this height over here from E to D. Now what do we know about this height? B, we know from B to C. From B, we're given that that's a 2. Okay, so B there, we're given it's -4 and 2. And C, we know that it's -1 and 7. We solved it there. So from 2 to 7, so 7 minus 2, because we want the y, we get 5. So the perpendicular height is 5. And then what's this final answer? A half times 6, that's 3. 3 times 5, that's 15. So 15 units squared. Yeah, well, you get the point, squared. Okay, that's it. Okay, let's do question 4.3. Let's take a look. So 4.3 says the circle centered at N is reflected about the line y is equals to x. M is the center of the new circle which is formed. The two circles intersect at A and F. Okay, so first of all, we have to kind of draw what they are saying here. Okay, let me just do this. I need the circle still, and I need that information. So this is now for, let's change the color. Let's go black. This is 4.3. Okay, so just to understand this question, so we've got this circle, okay, and it's got A and F, N, F, and it's reflected. So there's another circle that the deflection is gonna do. Okay, doesn't look like a circle. I need it to be a circle. Nah, okay, let's just leave it. Anyway, the circle centered at N is reflected, so we have a center there. It's N, and the coordinate is -1 and 3. About the line y is equals to x, so that line y is equals to x will be this line passing through these 2 points there, so that we get a proper reflection. Okay, so that's y is equals to x, and then M is the center of the new one, so the center of this one is called M, and by definition of reflection, y becomes x and x becomes y, so x here would be then 3 and y will be -1. Okay, so we've demonstrated that. Oh, also they say it passes through A, and F. Okay, that's where they meet. Cool. Now calculate the length of NM. Okay, so they want the length of NM. That's cool, we can jam that. So it's this length here. Let's calculate that quickly. So NM distance formula, square root of xn is -1 minus xm is 3, should be squared, plus yn is 3 minus ym is -1. This is squared. So what do we have here? We need to do some gymnastics, mathematical gymnastics. -1 minus 3, that's -4. 4 squared is 16, plus that's 4, so that's 16 as well. Okay, so nm is just the square root of 16 plus 16 is 32. Square root of 32 units. Cool. This was 4.3.1. Okay, and then they want the midpoint of AF. Okay, let's take a look here. Now the midpoint of AF is actually the same midpoint, that because the midpoint of AF is there. Okay, it's the same midpoint as of N and M. Okay, so then I can say 4.3.2 midpoint formula is x n plus x m divided by 2. You know, I don't need to write this formula again. You guys already know the formula, so I'm just going to write the numbers. Okay, so xn is going to be -1, x plus xm is 3 divided by 2, and then yn is 3 plus -1 divided by 2. What's this equals to? 3 minus 1 plus 3 is actually 2, so then I have 2 over 2, and then here 3 minus 1 is also 2 over 2. So that means the midpoint is 1 and 1. Okay, so just to make it look nicer, then you can say midpoint of AF is 1 and 1. That's the coordinate of it. Well, that's it. If there's something you didn't understand or you need extra help on these, please do contact us. Visit our website on www.mvtutors.co.za or WhatsApp us on 076-312-1107. Please, before you contact us, talk to your parents or your guardian. Let them know you need tutoring, you need our services. Involve them before you contact us, because remember, at the end of the day, they are the ones who are paying for our services, so they need to agree as well. Other than that, please like and subscribe to our videos and our channel, and thank you so much for listening. We appreciate you.
Alrighty, hello everyone and welcome back to MV Tears. Thank you for tuning in, and yeah, checking yourselves. How did you do with paper 2? So far, it looks like it was an okay paper, but now we're at trig. I know a lot of people struggle a bit with trigonometry and Euclidean, so I hope as we go through this, some things can be cleared up, you can learn something, and you can become better at it, especially if you're going to continue with maths and varsity. I hope this is quite fruitful for you. So please do not forget to like our videos, subscribe to our channel, spread the word, especially to the grade 11s that will be in matric next year, or for those of you who will be considering upgrading. Okay, so let us do it. Okay, so now 5.1, it says, without using a calculator, simplify the following expression to one trigonometric ratio. Let's do it. All right, so 5.1, we have sine 140 times sine 360 minus x all over cos 50 times tan negative x. Okay, so remember we have our Cartesian plane there. All smokers take cocaine. I'm kidding. That is what our maths teacher told us. Another way of remembering which one is where. But that's not true. That really is not true. But I mean, here I am so many years later and I still remember that. Okay. All right, so here all meaning sine, cos, and tan are positive, but on the second quadrant only sine is positive. Okay, where we have 180 minus theta. All right, on the third quadrant only tan is positive, where we have 180 plus theta. Okay, and on the fourth quadrant we have only cos that is positive. That is where we have 360 minus theta, or we have negative theta. The thing about cos, remember the graph for cos? Yeah, it's quite difficult drawing. But the graph of cos looks something like this. Okay? And if you look at it, you'll see that it's actually quite symmetric. It is symmetric about the y-axis. Okay? So, cos, if you have cos negative x, it's going to be cos x. Okay, if you have cos x, that's just simply cos x. Because it's symmetric about the y-axis, your negative angle inside doesn't affect it. It just becomes positive. Side note, let's start answering the questions. Okay, so sine 140, we are definitely in the second quadrant. Sine is positive, right? So we have a positive sign. And we want to, whenever you have an angle that is bigger than 90 degrees, you want to reduce it. We need to reduce it, guys, to an acute angle. So in the second quadrant, we know that it's 180 minus something that has to give us 140. So I would have to subtract 40 in order for me to get 140. Okay, so we are done with that. And then we multiply, or rather, let me just use a dot. Then we multiply by sine 360 minus x. 360 minus x is on the fourth quadrant. So sine is actually negative there. So that's just negative sine x. Okay. That is all over cos 50. It's already an acute angle. I'm going to leave it like that. Or, no, let me leave it for now. I'll change it later. Okay, and then we have tan negative x. Okay, so if you have a negative angle for tan and for sine, you must put the negative outside. Okay, but like I said, with cos it's different. If you have a negative angle, it's just going to be positive. Okay, so now we simplify again. If I have sine 180 minus 40, that'll just simplify to sine 40. Okay, I'm going to put the negative, this negative that we have there, I'm going to put it there. This cos 50, if you look at cos 50 and sine 40, they're actually complements of one another. They can cancel out, okay? And the reason why they cancel out, let me just move a little bit up. They cancel out because if I were to change cos 50 to sine, okay, let me just put it on the side there. So cos 50, I would have to say cos 90 minus 40, because if I subtract 40, I get 50, right? So what does the 90 do to the cos? It changes it to a sine, okay? Then we have a look. Cos 90 minus 40. 90 minus 40 is in the first quadrant. In the first quadrant, cos is positive, so this will be a positive. And then I reduce it then to 40. So I actually have sine 40 there. Or you could have changed sine 40 to cos 50. Doesn't matter. They are complements. Okay, at the end of the day, they cancel each other out. And then tan. Your identity, you know that tan is equal to sine over cos. So I have sine x here over cos x. If you're going to have a number divided by a fraction, you can actually take this up there. Okay, just to simplify life for yourself. So actually, I'm going to write there sine x times cos x. Okay, guys. Oh, there's a negative. I forgot that negative there that needed to be taken out. Okay, so the sine 40 cancels, the negative cancel, the sine x cancels. So one trigonometric ratio that we have there is cos. All right, and that was 5.1. Now let us go over to 5.2. All right, now we need to prove the identity. So we have negative 2 sine squared x plus cos x plus 1 all over 1 minus cos 540 minus x. Okay, and that is equal to 2 cos x minus 1. Okay, so we need to prove that the left hand side is equal to the right hand side. Definitely we're gonna try out the more complicated side, because how do you go from left hand to right hand? I mean, how do you go from right hand to left hand? Okay, so yeah, we're gonna try out the left hand side and until we get to the right hand side. Sorry for the background noise. My son wanted to feature in the video. All right, so what I'm gonna do here, remember we have our identities. You actually have them on your formula sheet, okay? I want to change the sine squared x to cos x because I can see I'm only dealing with causes here, and even in the final answer, I have cos. So remember our identity, that sine squared x plus cos squared x is equal to 1. So if I wanted to write in terms of sine squared x, that's just going to be equal to 1 minus cos squared x. So I have my negative 2 outside, and I'm just going to have 1 minus cos squared x. Okay, plus cos x plus 1 all over 1 minus. Okay, 540. Again, I'm going to draw the Cartesian plane. So here we have 0 degrees, 90, 180, 270, 360. 360 plus 90, that's going to be 450. 450, ne? Yes. Okay, and then 450 plus 90, that's going to be 540. These are all multiples of 9. Okay, I was taught when I think I read it in a book, if you want the multiples of 9, this is 9 times 1, and that's 18. So 10, and then 8, and then you have 27, and then 36, and then 45, and then 54. Okay, and then you have 63, 72, 81, 90. Okay, so that's how you do it on your hands. So we have, after 450, we have 540. Okay, so basically that's like saying cos 180 minus x. Okay, so no. If we are here, yes, so it is 180 minus x. It's the same as saying 180 minus x. And we know that we are in this quadrant. Okay, cos in that quadrant is negative. Okay, so we can just go and say negative cos x. Okay, I hope you get it. Okay, so what I'm trying to say really is if we have cos 540 minus x, it's the same as saying cos 180 minus x. And 180 minus x is in the second quadrant, and cos is negative there, so we have to put negative x. Okay, I am going to just shift because I've been writing a whole lot of notes. So let me just put that in a bubble. Okay, so equal to. Now I'm going to multiply everything out on the numerator. So I have negative 2. Actually, let me just put it in order once. Okay, so I'm going to negative 2 times negative cos squared. So it's going to be positive cos squared x. Ne? Then I have a plus cos x. And then I have a negative 2 plus 1. That's going to be negative 1. Okay, so that's on the numerator. And on the denominator, I have 1 plus cos x. Okay, so if you are confused with dealing with causes and sines and tans, you can change the numerator, guys. So you can say it for yourself. You have 2y squared plus y minus y. Okay, and then you can go ahead and solve. So I have 1 and I have 1. If I have a positive here, it means this needs to be positive and that needs to be negative. So 2y minus y gives me a positive y. And then you can take it back. Okay, so in one end you have 2 cos x minus 1, and then you have cos x plus 1. And in the denominator, I'm just going to swap the 2 so that I have cos x plus 1. Then I can finally scratch out or delete. And I'm left with 2 cos x minus 1. And if you remembered, it is the same as the right hand side. So we're pretty much done with that question. Not so bad, ne? Okay, and then now we are moving to 5.3. So given, so we have sine 36 is equal to 1 minus p squared. Guys, when you get this kind of question, especially if you look at 5.3.1, if they say determine without using a calculator, you know you must draw your triangle. Please, 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 please draw your right angle triangle. It will help a lot. So whatever they give you, if they say this trigonometric expression is equal to this value, always put a 1 underneath. And remember, with sine is always opposite over hypotenuse. Okay, so y over r. Okay, so if you have your right angle triangle here, okay, so if I have 36 over here, my opposite, okay, that will be 1 minus p squared, or root 1 minus p squared, and the 1, which is r, is going to be there. So if I need to determine what x is, I would have to use Pythagoras. So Pythagoras says hypotenuse squared is equal to opposite squared over adjacent squared. Okay, so I'm looking for the adjacent, which is x. So x squared is equal to r squared minus y squared. What is r squared? That is just 1. What is y squared? Well, basically it's the root 1 minus p squared. So the root and the square cancel each other. So I have 1 minus 1 minus p squared. If I remove the brackets, I have 1 minus 1 plus p squared. Therefore, x squared is p squared, right? And then if I want the value of x, that's simply going to be positive. It's not going to be the negative portion, it's going to be the positive one. Okay, so x is p. So we have drawn our triangle. We can then answer questions. It should be easy peasy, lemon squeezy. Okay, so yeah, tan 36. So if I'm looking for tan 36, well, what is tan? Tan is opposite over adjacent. Okay, so opposite, I have 1 minus p squared, and adjacent, I have p. And then that's it. We're done. So now 5.3.2. Yeah, maybe let me just put this in a bubble so that we do not think it forms part of the answer. Okay, so we have cos 108. All right, we have cos 108, meaning we need to reduce it to an acute angle. 108 is in the second quadrant. We already know that cos is negative there. So we have cos. And then what do we need to subtract in order to get 108? I think we need to subtract 72. Okay, so therefore we have negative cos 72. I don't know if you realize it, but 72 is double 36. Okay, so we can say negative cos 2 times 36. Okay, let me just lift it up. All right, and then this is a double angle. Okay, so you can, there are three ways, there are three answers for a double angle for cos. So you can use either one. I will go for, because cos 36 is just p, I will take the double identity where I just have cos. Okay, so let's just the reminder. So if you have cos 2 theta, it's either equal to cos squared theta minus sine squared theta, or it's equal to 1 minus 2 sine squared theta, or it's equal to 2 cos squared theta minus 1. So what I mean is I'm going to go with the cos option, because cos theta is equal to, or rather cos 36 is equal to p. So I'm just going to simplify my life. So I have 2 cos squared 36 minus 1. Okay, I still have that negative outside. So 2 p squared minus 1. And if I take out that, remove the brackets, I have negative 2p squared plus 1. Okay, and that is it. We are done with 5.3. No, we're done with question 5. We're done with question 5, guys. So I will see you next in question 6. All right, hello everyone and welcome back to MB Tutors. I'm Solo and I'll be looking at question 6 with you guys. All right, still on trigonometry. So let us see. All right, so 6.1, they have given us cos alpha minus beta. Okay, and they expanded it for us. So it's equal to cos alpha, cos beta plus sine alpha, sine beta. So whenever you need to expand this, the cos one, you're going to always get cos, cos, sine, sine. And the sign that you had initially, it will change once you expand it. So if you started off with negative, you're going to end up with positive. Okay, so yeah, this is what they gave us. And then 6.1.1, they say use the given identity to derive a formula for cos alpha plus beta. So this cos alpha minus beta, it is important because from there we can derive cos alpha plus beta, we can derive sine alpha minus beta, and we can also derive sine alpha plus beta. Have a look at your textbook. they should have derived all of them, and it is examinable. Okay, I haven't seen this question in a while, so for a while there, I think if I were writing, I would have forgotten, in all honesty. So yeah, but they expect you to know how to derive all these other three, even to derive cos alpha minus beta, and there's a way. I'm not going to get into it now. So now we need to get cos alpha plus beta. And we need to derive that using cos alpha minus beta. So what you would do, okay, if I need to have a negative there, I would say cos alpha minus beta. That for me is the only way I can get it to be negative, okay? So I need to just take out a negative, but I know if I were to multiply this back in, I would get a positive again, okay? And then once I have done this, I'm pretty much going to expand it, okay? So I have cos alpha times cos negative beta, okay? And because we have a negative there, we're gonna have to have a plus there, okay? So cos, sine. So sine alpha times sine negative alpha, okay? And then we go back to what do we do when we have negative angles? Okay, in question 5, I explained that for cos, a negative angle for cos, it doesn't matter, like cos negative 45 is just equal to cos 45, okay? So with this negative angle here, we actually have cos alpha, cos beta. But with a negative angle for sine and for tan, if you have sine negative 45, it's going to be negative sine 45. If you have tan negative 45, it's going to be negative tan 45. So that is where it actually matters. And you'll see when you sketch the graph. Okay, I showed you guys in question 5, but I can show you again. When you have cos, the cos graph looks like this. It's symmetric about the y-axis. So that's why you get the same answer regardless. But if you look at sine, on the positive side, it looks like this. On the negative side, it looks like that. So that's why you would get negative. If you get a negative angle, if you have sine negative x, your answer is going to be negative sine x. And also with tan, so I'm going to use 90 here and negative 90. Which side does it go on? So on the positive side, it looks like that, but on the negative side, it looks like that. So yeah, it's only cos that remains positive regardless of whether the angle is negative or positive. Okay, so getting back to our question over here, we know that cos negative beta is just cos beta. And then here we have sine alpha. Oh yeah, that has to be negative because of this negative angle here. So that's going to be negative. Oh gosh, what did I do? I wasn't focused, but at least I saw my error. Okay, so the negative falls outside and we have that. And yeah, that is it, guys. This would be your answer. Okay, like I said, with cos, you have cos, and if it was a positive here, you're going to end up having a negative here, and that's how you actually derive it. Okay, so now we get to 6.1.2. All right, simplify completely. Okay, let us see. What is it that we need to simplify? This looks like some hectic stuff here. Ooh, cos 6x, and we have cos 4x. Okay, and then we have minus cos 10x plus 2 sine squared x. Okay, this is like hectic stuff. All right, so for now, I'm gonna leave this 2 cos 6x and 4x, okay, because if I start trying to expand it, it's gonna be complicated. I mean, 6x, it can be 1 plus 5, it can be 2 plus 4, it can be 3 plus 3. So which one do I choose? If I take 4x, it can be 1 plus 3, can be 2 plus 2. So let's just wait a bit. But this cos 10x, I can expand it. Okay, I already know here we have 4 and we have 6 and we have 4. So I can then say 6x plus 4x, right? And then this one, I'm not so sure what I'm going to do with it for now. So I'm just going to leave it like that, because sine squared x, you can change it to cos squared x, okay? So I'm not ready yet to do anything with that. Okay, so I'm just going to say 2. This one, I'm still leaving it as it is, cos 4x, and then I'm going to expand this. So I have cos, let me put a bracket. I have cos 6x, cos 4x, and we have a plus here, so I'm going to have minus sine 6x, and then I have sine 4x, okay? And I'm still not sure what to do with this. It'll get clearer as I move on. So if I take out the brackets, I have 2 cos 6x cos 4x minus cos 6x cos 4x plus sine 6x sine 4x, okay, and then plus 2 sine squared x. Okay, so now I have cos's and I have sines. So I'm really still not sure what I'm going to do with the last one. I'm going to leave it. Okay, let me just take the page further up. Okay, so what do I see here? This is common, right? I have 2 and here I have 1. So 2 minus 1, I'll be left with cos 6x cos 4x. Okay, then I have plus sine 6x sine 4x plus 2 sine squared x. Okay, so if I look at this, I have cos cos, sine sine. So it is a cos identity, and I have 6x. Remember, if it's a plus here, it's gonna be a negative here. Okay, so at least it's getting much better. Okay, we'll see what to do with this. So 6x minus 4x, that's 2x. So I have cos 2x plus 2 sine squared x. Okay, now I know what to do. Okay, it's getting clearer, much clearer. So remember, cos 2x, it has 3 identities. You either have cos squared x minus sine squared x, or you have 1 minus 2 sine squared x, or you have 2 cos squared x minus 1. I will go with the sine one. Okay, so 1 minus 2 sine squared x plus 2 sine squared x, and I'm smiling because I can see things are cancelling, which is great. My answer is therefore 1. Okay, and we are almost there. We are now doing question 6.2. It says determine the general solution. Okay, so we're getting the general solution of 10x. You know this question is going to come up. They always ask for the general solution. Okay, so 10x is 2 sine 2x, okay, where cos x is smaller than 0. So that's a clue. Now let us see what we can do. I am going to expand what I know. So sine, or should I leave it? Okay. Should I change it now or change it later? No, actually, let me just leave it because I don't even know what the other side looks like. Okay, so let me expand this side rather. But we'll see. Probably things are going to cancel. So I have 2. So sine 2x, the nice thing about the double angle for sine is there's only one answer. So sine 2x is 2 sine x cos x. Okay, I'm going to expand this. 10x is equal to sine x over cos x. Okay, so what will I do? I will then take cos to the other side and sine to the other side. Okay, so I'm going to divide by sine here, but the signs are actually cancelling out. But with me dividing it, it just shows that they really are cancelling out. Okay, and I'm taking cos to the other side. So cos x times cos x. So I move the cos this side, and I move the sine that side. So I'm going to have to divide by this, and I'm going to have to multiply by that. Okay, I hope I did not lose you there. So now I have 1, and then I have 4 cos squared x. Okay, I'm going to put the cos squared x this side, but I need to divide by 4 both sides. So I have a quarter. Okay, if I move that up, if I put roots on both sides, so here, the clue here, remember, if you're gonna root both sides, you're gonna be left with cos x, right? Equal to a half or negative a half. And they clearly told us there that cos x has to be smaller than 0. So we are actually dealing with negative a half only. Okay. We're not considering a half, which makes life a little bit easy for us. We don't have to get many general solutions. So when you get here, guys, there are 2 ways of doing this. You could either get the reference angle for negative a half, okay? And then when you get the reference angle for negative a half, when you take it as a whole, you look at where cos x is positive. Cos x is positive on the first and the fourth quadrant, okay? But if you take the reference angle for just the half, remember there's a negative here. How do you then account for this negative? You tell yourself that cos is negative on the second and third quadrant. Okay, so there are 2 ways of doing it. You decide. I will do both for you guys so that you see that you get to the same answer. And then you in the exam will tell yourself, I'm going to go with this way. This is what I understand. Okay, so I'm just going to divide that. Okay, so if your reference angle is negative a half, if you take your calculator and you say shift cos negative a half, you're going to get 120. Okay, so therefore your reference angle x is equal to, or rather let me just say reference angle. So your reference angle for negative a half, that's actually 120 degrees. But if you're saying, I just want the half, you're going to get your reference angle to be 60. Okay, now I'm looking at the first and the fourth quadrant. Ne? So on the first quadrant, I know that x is equal to the angle that we have, our reference angle, which is 120. And we know the period of cos is 360, the period of sine 360, the period of tan is 180. But here, because we have cos, we're going to use the period of cos, which is 360. And you have to say k is an element of integers. So for k, it can go from negative whole numbers to positive whole numbers. You can't have fractions for k. Okay. So that is our first solution, 120 plus 360k. And then in the fourth quadrant, we know that cos, so in the fourth quadrant, it's 360 minus the reference angle. Okay, again, plus 360k, where k is an element of integers. Okay, so 360 minus 120, that should give us what? 3 minus 1 is 2, it's 4. That should give us 240k plus 360k. And those are your 2 solutions if you went with this reference angle of negative a half. But if you go with this one, the reference angle of a half, and you're accounting for the negative by saying cos is negative in the second and the third quadrant, this will be your solution. Should be the same. So in the second quadrant, we know that we have 180 minus the reference angle, which is 60. okay, and then plus 360 times k, where k is an element of integers. Okay, so 160 minus 180 minus 60, that gives you 120, okay, plus 360k. Okay, and then if you look at the third quadrant, we have x is equal to 180 plus the reference angle, okay, plus 360k, where k is an element of integers. So 180 plus 60, that's 240, plus 360k. Okay, so those are your two answers, the general solution. And as you have seen, it's the same, 120 plus 360k, 240 plus 360k. So it really depends on you, what flows your boat, and yeah, you're good to go. So we are done, guys. Question 6 was nice and short and sweet. I'm not forgetting anything, right? Let's see. Yeah, I think we're good. Yeah. Okay, this paper's, yeah. We're done with question 6. All right, thank you guys for tuning in. I'll see you next in another question. Hello everyone, and welcome to MB Tutors. I'm Tsolo, and I'll be looking at question 7 with you guys. We are ending off the... No, actually we're not. We're just looking at trig graphs. Okay, we're not ending it, the trig section. There's still question 8 for that. But yeah, let's just see what question 7 requires from us. Please don't forget to like our videos and also subscribe to our channel and spread the word to those who are going to be upgrading next year, or the grade 11s that are going to matric next year. So now question 7. In the diagram below, the graph of f of x is equal to negative 2 sine x. Okay, so basically you took your original sine x graph, okay, and then you multiplied the amplitude by 2. So instead of now it having a maximum and a minimum at 1, it's now going to be at 2, right, and negative 2. And then what you also did, you made this the graph negative. So instead of starting off at 0, going to 90, and then finishing off at 180 on the right hand side, it does the opposite because it's negative. So it's flipped around, and it's flipped about the x-axis. Okay, so that's it. And then 7.1 says, on the grid provided in the answer book, I don't have that, draw the graph of g of x being equal to cos x minus 60. So what is that exactly? So if I were to sketch the graph of g being cos x minus 60, it basically means I have my original graph. Remember, cos starts here and it goes all the way to 90 and then 180, and then it comes back up and then finishes off at 360. And then this side again, same thing till 180 and then finishes off to 360. Okay, but now what happened? There was a shift, a horizontal shift. Okay, here we magnified and flipped it. Here we are shifting it horizontally. Okay, so the sine graph was magnified and flipped. The cos graph is shifted 60 degrees, but is it 60 to the right or 60 to the left? If ever it confuses you, just say x minus 60 is equal to 0. If you get a positive, it means it's shifted to the right. If you get a negative, it means it's shifted to the left. Okay, so cos x minus 60 is actually 60 units, or rather no, 60 degrees shifted to the right. So our graph would then, instead of 0 here at 60, you would start it and it would just go. And instead of ending at 180, okay, we would add 60 to it, so it end at 240. Okay, so it will shift like this. So yeah, it will be something like that. But we're gonna sketch it, and if you want to be accurate with your sketches, I would suggest you use the table method on your calculator. Okay, just so that you are accurate. So how do you do it? You go to mode setup. If you have the darker calculator, the table I think is on option 3, but this is a more advanced calculator. I don't even know if this is allowed in the exams, to be honest, because you can actually solve for x here. You can solve for a lot of things. This calculator is nice. It's very useful in varsity, but I don't know if it's accepted in matric. So we're gonna put in the equation. I hope you saw what I did there. So click on cos and then alpha to activate the x, and then minus 60. Okay, and then we are starting at negative 180. We are ending at positive 80. And our steps, if you look at it, we're actually moving in steps of 30. Okay, so it's 30, 60, 90, 120, 150, 180. So steps of 30. Please do not select steps of 1. You're not going to finish. And it'll tell you it doesn't have enough memory for that. So for negative 180, we actually have a half. Sorry, negative a half. So negative a half is actually, let me use black this time. Negative a half is there. Okay, and then for 150, we have negative 0.8. So negative 0.8, it's very close to 1. So I'm just going to put it somewhere there. Okay, and then 120, we have negative 1. Sorry, negative 120, we have negative 1. And then we're going to go down. So negative 90, again, we have that negative 0.8. This is going to be tough sketching it, but we will try our best. Okay, and then for negative 60, we have a half again. Okay, and then for negative 30, we have 0. Okay. Remember the side at negative 240 would have been 0 there. Okay, but yeah, anyway, for 0, we have positive a half. Okay, and then 30, we have that value there. And then 60, we have 1, which makes sense. So 90 is going to be that value over there. That's going to be a half. Okay, for 120. And then 150 is going to be 0. And then 180, negative 0.5. Okay, now the difficult part. Putting the dots together. Let me just choose a thinner mark. Okay, let's do this. Okay, so far not so bad. Okay, I'm gonna do this side first. Okay. Yeah, being left-handed. Okay, now let's see. I'm gonna do this side. Ooh. Okay, but anyway, doesn't have to be perfect. Okay, so we have our graph there, and that one is G. Okay, and we have F. All right, so we drew. What else do they want to see? They said clearly show all intercepts with the axis. So here we have negative 30 and 0. Okay, that is with the x-axis. And here we have 150 with the 0. Here we have a half, or rather 0 and a half. Okay, and what else? Yeah, that's the axis. And then we showed the intercepts and the turning points. Okay, so turning point here, it will be negative 120 degrees and minus 1. Okay, the turning points should be at 1 and minus 1 in any case. And then here we have 60 degrees and 1. I think we've indicated everything. Yeah. Okay, let's go to the next question. So that is your graph, guys. Okay, 7.2. write down the period of f 3x. So if ever you're looking for the period, so period is equal to, remember for a sine and a cos graph, it's 360, right? If it was 10, it would be 180. So 360, and we divide it by the frequency. Okay, so the frequency that we have there, the frequency is really the coefficient, yes, terms. It's really the coefficient. I don't know if I spelled it correctly. Coefficient of x, okay? And in this case, the coefficient of x is 3. So basically, we're going to say 360 divided by 3, which is 120. That is the period. Okay, so what does it mean? It means for it to complete, so if I were to look at the, what is it? The interval of maybe, let's say, from 0 to 360, I would fit in 3 full waves. Okay, if my period is just 360, if my coefficient of x is 1, then it means I fit 1 wave in 360 degrees. But if it's 3x, it means I fit 3 waves in 360 degrees. Okay, cool. Because 120 fits 1 wave, and another 120, and another 120. I hope it makes sense. All right, and then now 7.3. So now it says use the graphs, guys. When it says use the graphs, please don't calculate. You're not gonna get the marks. Okay, maybe half, but use the graphs. So it says use the graphs to determine the value of x in the interval, so the domain, which is negative 180 to 180, for which f of x minus g of x equal to 1. What does that mean? It means if I look at the y values for f and I subtract the y values of g, I must get 1. Okay, so let's have a look at this. Ne? Okay. Oh, man. So remember here, we had 0,5. Ne? I'm just going to put the y values. We had negative 0,5. Okay. And for this value here, we have 0. So that does not give us 1. 0 minus 0,5, that's just 0,5. Here we had that 0,8 something something. And you can see here already that's 1. So that's not going to work either. Here we have negative 1 and we have a value more than 1. Not going to work. Here we have a value of 2. Okay, so 2 minus 1, that's like, okay, 2 minus 0,8, that's already more than 1. Okay, that's 2,8 something. So it's not working out either. And then here at negative 60, you have again 0,5. Okay, and there you have what, 1, something. Still not working out. But here at 30, guys, or rather negative 30, you have 0 here. The y value is 0, and the y value there is 1. Okay, so f of x is 1. Okay, we have that at 30 degrees, at negative 30. Okay, let me rather do this. Ne? Okay, at x is equal to negative 30 degrees. Ne? F minus g is equal to 1 minus 0, which is 1. So we know minus 30 degrees works. Okay, I erased my things there. So I have 0 there and I had 1 there. So that's great. Here at 0 degrees, I have 0 for f and I have 0,5 for g. So that's not going to work. Here I have minus 1 and there I have 0,8. It's not working. In this on the right hand side, okay, of your x-axis, it's not really gonna work because f is negative. Okay, so you're gonna get what, the closest we can get, if we look at 150, right, we have our x value and we have -1 and we have 0 there. So -1 minus 0 is going to give me -1. So nothing works this side. So our only solution, therefore, is going to be x is equal to -13. Okay, hope it makes sense. And then now 7.4, which is our last question. Now it says, write down the range of k. So what is happening with k? So k is where we take g and we half it. We're taking half of g. So the amplitude now is going to be a half, from -1/2 to +1/2. Okay, so we half it and then we take it up 1 unit. How will that look on our graph? Let me see if I can sketch it. Okay, so if we half it, our graph is now going to go from -1/2 to +1/2. It's going to be like reduced. Okay, I don't want to say reduced, man. So if you expand, it'll be contracted. Yes, it'll be contracted. So this whole graph is going to fit in that contracted portion. And what are we doing now after it's being contracted? Okay, so like I said here, we're going to go from -1/2. This pen is so thick. Okay, we're going to go from -1/2 to +1/2. Okay, and then we shift it. We have a vertical shift. Now it's shifted 1 unit up. So that -1/2 plus 1, it is going to be +1/2. So it's going to be there. And that +1/2 plus 1 is going to shift to 1.5, or 3/2. So now our graph is going to fit in between there. I'm not going to try to draw it now because I just might ruin it. But it says write down the range of k, guys. So the range is basically all the y values. Okay, so our y values are really going to go from +1/2 to +1.5. That will be our range. Okay, so how do I put that? I'll say y is an element of, and it's included. Okay, so it's going to be 1/2 all the way to 1.5. Okay, that is our range. Okay, yeah, and that's it for question 7. We are done. I will see you guys next time.
Well, good day to you. Welcome to MV Tutors. My name is Figa Manana, and we are still doing the November 2021 paper 2, and we are now on question number 8. Well, let's get right into it. So, question 8 says, in the diagram below, T is a hook on, where's T? Oh, there. Hook on the ceiling of an art gallery. Point Q, S, and R are on Q, where's S and R are on the same horizontal plane from where 3 people are observing the hook T. Okay. The angle of elevation from Q to T is X. From Q, so that's from the floor to that angle there, to T is X. And then QSR, okay, is 90 plus X. I see it. QRS, where is R? Oh, RS is also X. And then QR is 5. QR is 5 units. And then TS is equals to SQ. So TS is equals to SQ. Cool. All right. What's the first question? Prove that QS is 510 that. So where's QS? Now, whenever I do these questions, I like to take out the triangles that I will be working with together with the information I will need from them. So QS, which triangle can I use? I'll use the bottom triangle because it has most of the numbers. So if I look at that bottom triangle, really it's more or less like this. Okay, and this is where I've got Q right there, I've got R, and then I've got S, and then what else do I got? I've been told this is X there, and this one, this angle there is 90 plus X, and I'm looking for QS. So I can use the sine rule over here. So I can say QS divided by sine, what's the opposite angle? It's X. Oh, I've got 5 here as well, forgot that. Is equals to QR. QR is 5 divided by sine, the opposite angle is 90 plus X. 90 plus X. Okay, so now just have to do some mathematical gymnastics. So it's 5 sine X divided by, I just multiply both sides by sine X to get rid of it at the bottom there. What's sine 90 plus X? That's cos X, and then that is 5. Sine over cos is 10 X. There we go. Cool. Right, and then they say prove that the length QT is 10. Okay, so now we're looking for the length of QT. All right, do the same. Take out the triangle that we are going to need in order to solve QT. It's basically this triangle there, and it's a little bit like this, right? Good. So that's T there, and we've got Q there, and then we've got S there. So we've been told that this length and this length are the same, and I've been told that's X. So equal lengths, this is an isosceles triangle, which means it also has equal angles there. And then this one, this angle here, remember, if I add up angles in a triangle, they equal 180. So this angle over here is just gonna be 180 minus 2x, right? Yeah, it's gonna be 180 minus 2x, which is the same as 90 minus x, really, if I'm to simplify it. Okay, but let me leave it like this for now. It's okay. Okay, so prove that QT, we're solving for QT. Okay, so QT, I can use the sine rule again. QT divided by sine 180 minus 2x is equals to which length do I have? Okay, I can say, didn't I just solve QS? QS is 5, 10 x. Cool. So that's what I'm gonna write. QS is actually 5, 10 x divided by the opposite angle, which is sine of x. Okay, let's do some gymnastics once again. It's gonna be QT is equals to 5, 10 x times, what's sine 180 minus 2x? So if we have cast, 180. So sine is positive in that quadrant, so it's gonna be sine 2x divided by sine x. Cool. Let's continue. Now all we need to do is just to do some more gymnastics over here. Okay, so 5, let's simplify this. 10 is sine x over cos x. Okay, and then on top again, sine 2x is 2 sine x cos x, and then that's also divided by sine x, so that's that sine x there, it's just the same. Okay, now I can cancel them. That cancels that cos, and then that sine cancels that sine. Then I'm left with 5 times 2, which is 10, and then that sine x, just like that. So this is qt, 10 sine x. Yep, we proved it. Okay, let's do the next one now. Calculate the area of triangle TQR. Where's TQR? TQR. And the angle TQR is 70. And then, okay, likewise, like I said, you know, I just want to draw. Always with these questions, I always draw the relevant triangle, because there's too many triangles there, so you need to be able to draw the one you're working with. So I'm working with this one here. It's like this, really. Okay, so what do I have? I have that's Q, that's T, and then that's R. Okay, and then TQR is 70, so I got 70 degrees there. And then X is 25 degrees. Okay, the reason they gave me that is because I'll need it for, remember QT is 10 sine X. Okay, and I need QR as well. QR is 5. So what I'm gonna do is the area formula, it's in your formula sheet, so I'm not gonna write it, but it's let me just write it. It's half, and then I need these sides, which is QR times Q T, and then times sine of the angle that's in the middle, which is 70. Okay, let's get more space and do some mathematical gymnastics. All right, so a half stays there. QR is 5, QT is 10, sine X we're told is 25, so we'll put that in. And then sine of 70. You know what, I'm just gonna put this in a calculator real quick. So I have a half, which is 0.5 times 5 times 10 sine 25 times sine 70, a 9.9. Okay, 9.9 units squared. Okay, that's it. Let me see, is there another question? That's all. Okay, that's it from us. Well, if you didn't understand anything or you need extra help on these, please do contact us on our email, which is www.mvtutors.co.za. Alternatively, you can WhatsApp us on 076 312 1107. And before you do, please make sure that you have spoken to your parent or your guardian, because they are the ones that are paying at the end of the day, so they need to be involved in the process, and we would love to be of service to you. Well, thank you so much. I hope you understood, and we appreciate you. Welcome to MV Tutors. My name is Figarahle Manana, and I'm your tutor today. Well, we're still doing your final exam. This is the November 2021 Maths Paper 2. It's not Paper 1, it's Paper 2. Paper 2, and this is question number 9 now. Okay, well, let's get right into it. So in the diagram, PQR is a cyclic quadrilateral. So PQRS, there they are. PS is produced to W. PS is produced to W. That means it's a straight line whenever they say produced. Now TR and TS are, where's TR? TR and TS are what? Tangents to the circle at R and S respectively. Cool. Now the angle of T is 78, of Q is 93. Thank you so much. What's the question? Give reason why ST was ST. ST is equals to TR. Wow, that one is short. As you can see from the diagram, they're from the same point. Okay, they're from the same point. Therefore, okay, so question 9.1 says give a reason why ST is equals to TR. Well, as you can see, they are from the same point T. Okay, T. So you can just say that. That's question 9.1, right? Good. So question 9.1, we can say ST is equals to TR, and the reason is because why? Same point, and that same point is T. Okay, that's it. I'm just gonna say that. Okay, so same point T theorem. Then 9.2 says calculate giving reasons the sizes of S2. S2 is over there. Okay, so now what I'd like to do is actually 9.2.1 is draw what I need to answer this question. So just to take out what I need this triangle. So what do I have? I have a triangle that's like this, right? And then that's S there, that's T there, and that's R. So I know that ST is equals to TR. So I have an isosceles triangle, and then I have that's 78, the angle they make between them, which means the S and R are sharing are the same. Okay, I'll call this one S2 actually. So S2 plus R plus 78 is equals to 180. What's the reason for that? Yes, you know it. The reason is because angles of a triangle. Okay, so angles of a triangle are equal to 180 when you add them. So what else do I know? I know that S2 is equals to R. Why is this? That's because we have an isosceles triangle. Isosceles triangle. So by isosceles triangle, same sides, same angles. So to continue here, then I have S2. I'll substitute. Let me just write it for you. S2 plus S2. I just substituted the R with the S2. Plus 78 is equals to 180. Okay, now we'll just do the mathematical gymnastics. So then I have 2S2 is equals to 180 minus, I want to put that in a calculator. Let me get a calculator there. So I have 180 minus 78, and that gives me 102. And then S2 is 102 divided by 2, which is 51 degrees. There we go. Is that all they wanted us to solve? Let's see. Yes. Okay. Now they want us to solve S3. Okay. What do I need here? Let me take the entire cyclic quad. This is now question 9.2.2. They want S2. And what I want to do is draw that cyclic quad first. It's like that, right? And then it has that. So that's P, that's S, that's Q, and that's R. Okay, and then what do I have? I have 93 here, the angle, and then here I have another one that's like that. That's S3, and that's S2. So then from this diagram I can say S3 plus S2 is equals to 93. And the reason is because it's an external angle of cyclic quad. Okay, external angle of a cyclic quad are the same. Okay, so now S3 plus S2, what's S2? We just solved S2 to be 51 is equals to 93. Let's get more space to do some mathematical gymnastics. So S3 really is just 93 minus 51. 93 minus 51. So it's 42 degrees. That's it. That's it. Well, I hope you understood everything that we did, but in the event that you didn't, please do contact us. You can visit our website www.mvtutors.co.za, book a free consultation with us. Alternatively, you can WhatsApp us on 076 312 1107 to book a session. And please, before you book a session, talk to your parent or your guardian or whoever is going to be paying for the session. Involve them before you contact us. Okay, well, other than that, please like and subscribe to our channel and this video as well. And thank you so much. I hope you understood everything. We appreciate you.
Hello everyone, and welcome back to MV Tutors. I'm Tsolo, and I'll be looking at question 10 with you guys, Euclidean, and we are almost there. All right, so in the diagram, BE and CD are diameters of a circle having M as a center. So as I read this, I just want to start sketching for myself. Okay, so BE, okay, we can see it. I'm gonna mark it with green. So it's gonna be a tough one, but yeah. Let me choose this thicker color. Okay, so BE is a diameter, right? And if it is a diameter, it means the angle that it subtends is going to be 90 degrees. So A2 plus A3 are 90 degrees. And then what else do we have? Okay, let's see. It says CD is also a diameter. So we have a look there, and they're both passing the center M. It's nice when we have centers. You know what, there's a likelihood we're going to use angle at center as a reason some way. So basically A1 and A2 give you 90 degrees. All right, chord AE. Okay, so this is A and that's E over there, is drawn to cut CD at F. Okay, and as you can see, F is part of the line, part of the diameter. Okay, so yes, indeed, if you're gonna go from the center to a chord, you're gonna have 90 degrees. Okay, so it says AE is perpendicular to CD. Yes, that is true. And then let X be, let's see the X. Okay, all right, so let us go back now to our normal blue. Now it says give a reason why AF. Okay, so this is A. Okay, and that is F. So give a reason that AF is equal to FE. Oh, okay. So you know that from your center to the chord, okay, you are gonna have a perpendicular bisector, so that the line from the center to a chord actually bisects the chord. Okay, so how are you gonna put that nicely in words? So 10.1. So we have line from center. Yeah, it would have helped if I had, if I could see the marker location to see how much I should explain. Okay, so basically, I would just say line from center to chord bisects the chord. I like saying here that if you can't remember the shorter description, write the sentence. Write a paragraph or essay if you need to, as long as you get the marks. Okay, don't write an essay or a paragraph, just stick to a sentence. So line from center to chord bisects the chord. And which one is the line from the center to the chord? It's CD, right? And it bisects which chord? Chord AE. Therefore, AF is equal to FE. And you can also indicate on your sketch there that these two lines are actually the same length. All right, and then we get to 10.2. Okay, so now it says determine, giving reasons, the size of M1 in terms of X. So what is M1? Okay, I'm gonna choose now a different color. Is there an orange? Yes, we have an orange. So this is M1 over here. Guys, when you're doing Euclidean geometry, please have colored pens. It will help. So what is the size of M1? I know that M1 is the angle at the center, right? And that angle is subtended by this chord CE. Let's attempt to draw a straight line. Yes. So CE subtends this chord M1 at the center. Is CE also subtending another chord at the circumference? Okay, it is. If you look here, it is subtending. Ooh. So it is not only subtending M1, but it is also subtending A1. Okay, so it's subtending both A1 and M1. M1 at the center, but A1 at the circumference. Okay, now do I know what A1 is? Yes, I do. I do. So if I look at triangle ACF, which is a right angle triangle, I know that C is already X, so A1 will be 90 minus X. Okay, so let's write everything down. Let's write all those things that I'm saying. Okay, so in triangle ACF, okay, ne, C is X, F is 90 degrees, therefore A1 is 90 minus X. And how do we know that? Well, sum of interior angles of a triangle, okay, because they're always equal to 180. So that's how we know it. So we have A1. Okay, now we say that M1 is equal to 2 times A1. Why? Because of angles at the center. That's the shorter version. But basically, a chord that subtends an angle at the center will subtend an angle at the circumference, which is half of the angle at the center. Okay? So, yeah. Therefore, the angle at the center is twice the angle at the circumference. So we know that A1 is 90 minus X. So if we substitute it in, it's going to be 180 minus 2X. Okay, that is M1, and we have it in terms of X. Okay, so we are happy. Now we get to 10.3. Prove, giving reasons, that AD is a tangent to a circle passing through AC and F. Okay, so prove, giving reasons, that AD is a tangent. Okay, let's go. Okay, I will then use purple. Okay, purple. Okay, so we need to prove that AD is a tangent. Okay, so we have a tangent, and it's a tangent to a circle passing through A, C, and F. So this is F. How will that circle look? Okay, so I'm gonna attempt to draw. No, it is not working out the way I'm trying it. Okay, so it will do maybe something like this. Okay guys, obviously it's not going to be perfect, but yeah. And then AD is just a line pretty much perpendicular, no, tangent to that circle. So our circle is going to look something like this. Okay. Yeah, this is how our circle is going to look. Something along those lines. So now we need to prove, giving reasons, that AD is a tangent. Do you remember the tan chord rule? So basically, if you find yourself having a triangle inside your circle, okay, you can then safely say from this side, we could say that A2, okay, A2 is equal to X. Okay, or you could prove that this angle here, so 90 degrees here, because I mean A1 and A2 are equal to 90, so this one also has to be 90 because it's on a straight line. So 90 here is equal to 90 there. So you can either prove either way. Okay, that's actually a simpler way. But yes, we can already see that if we have 1, 2, 3, let's just call that A4. A4 is 90 because of angles in a straight line, and we have 90 degrees there at F. Okay, so that's the tan code theorem. We already proved it. Or we can prove that A2 is equal to C. Okay, how are we going to prove that A2 is equal to C? Let's say you decided to go that route. Okay, so we have to show that A2 is actually equal to X. Yeah, that's basically what we are going to show. Okay, so that might actually take a bit of a while, but yeah, let's see. Okay, 10.3. Okay, so we are actually going to have to show that A2 is equal to X. Okay, as I had sketched there, I don't think they would take my A4 reason. Okay, so let's just be safe and go with A2. And how exactly are we going to show that? Okay, so I've already marked my paper, like, yeah, it's quite heavy. So I'm gonna just remove everything else and see how we can do it. But by looking at A3, A2, A1, let's see what we can come up with. Let me just try to erase the busyness over here. Let me just, yeah, delete that maybe. Let's see if we erase them. Is it gonna erase everything? No. Okay, thank goodness. Okay, all right, so let us try to attempt this. We have a circle here, right? And AD is there. So I'm trying to prove that A2 is equal to X. And we know that we have our right angle triangle here. And we also have, let me use a different colored pen. We have our right angle triangle. And we also have our other right angle triangle. Okay. So what I'm going to do, guys, I'm thinking of, yeah, Euclidean. Let me choose a different color. Let's go to black. I'm thinking of using BD as a chord. Okay. If I use BD as a chord, BD subtends A3, and BD also subtends M3. And I know that M1 is actually equal to M3, okay, because of vertically opposite angles, okay? And I would know that A3 is half of M3 because of angles at the center. So let's just write all those things down before we forget. Okay. So, I know that M1 is equal to M3. Okay, I just solved M1, which is 180 minus 2x, vertically opposite angles. Okay, and I know that A3, I'm just going to keep referring to this sketch here so that I don't go up and down. So I know that A3 is actually equal to half of M3. Okay, and that is angles at center. Okay, so what exactly is A3? Well, A3, sorry about that. So I'm gonna have 90 minus x. Okay, so that's A3. A3 is actually equal to A1. Okay, so that is A3. Okay, now I'm not done. I need to show A2 is actually equal to X. So if I take A2 and A3, remember there's a what do you call this? The diameter EB, it subtends A2 and A3, and A2 and A3 is actually equal to 90 degrees. So A2 and A3 is equal to 90 degrees. Why? The chord is the diameter. Okay, so chord EB is diameter. Okay, so I have A3. Now I need to solve for A2. So I know that A2 is equal to 90 minus A3, which is actually 90 minus 90 minus x, which is equal to 90 minus 90 plus x, which is just x. Okay, and that x, we can therefore say A2 is equal to c, which is equal to x. Okay, and therefore AD is a tangent passing through circle, circle A, C, and F, and that's due to the tan chord theorem. That's what we actually used here to prove that it is tangent. We use the tan chord theorem. As soon as you have a triangle in your circle and you have a tangent line, think about the tan chord theorem. Okay, so we're good with that. And then 10.4, I don't know, is it the last question? Okay, so they say given that CF is 6 units and AB is 24 units, calculate giving reasons the length of AE. Okay, let's go and put in these values. Okay, this might be a long one. Okay, we have that CF. Maybe let me just put in a new image. I've drawn so much on that one. Okay, so let's just put in a new image. Okay, so what are they saying? All right, so they say CF is 6 units. Okay, so this, we have 6 units and AB is 24 units. Where is AB? Okay, AB, really? CF is 6, AB is 24? AB looks like it should be 12, but it's not drawn to scale. So AB is 24 units, and then calculate giving reasons the length of AE. Okay, so this is AE that we are looking for. Okay, we already know that this is already a right angle triangle, right? Okay, so here's what I'm thinking of doing. Ooh. Okay, I know my face is covering. Sorry about that. Maybe let me try to, no, I can't reduce it anymore. Okay, so here's what I'm thinking. Or rather, let me draw to the side. Let me just, so that you guys can see everything. I have 2 right angle triangles, okay? So I'm gonna try to see if they can be similar some way. And then I can then use the rule, or rather the theory of similarity, to then get AE. We'll see. Okay, so if I were to draw CFA, so C, F, and A. Okay, so I know that C is X. Okay, and then we have F, and then we have A1 there. All right, and then I'm gonna look at the big triangle. I'm also gonna try drawing it this way, but just a lot more bigger. Okay, let me start here. Okay, much better. So with this big triangle, that's the 90. That is where A is. Okay, and then it goes all the way to E, and then we have B. All right, so I know that CF is 6 units, né? And I know that AB is 24 units. Okay, now that I know all of that, how does that help me? Is there a way of showing that B is equal to X? Yeah, that's pretty much what I want to get to. How can I get B? How can I also get E? Okay, we already know that M1 is 180 minus 2x, which is M3, 180 minus 2x. I know that A3, we did it before. A3 is 90 minus x. Let's just put in everything we know. Okay, A1 is also 90 minus x. A2 is x. What else do we know? This is also a right angle triangle there. Can I use it? I don't know. Maybe. Let's just see. So if I draw out that triangle, okay, doesn't matter. So I have F, and the reason why F is 90 degrees is because it's vertically opposite. Okay, vertically opposite there. Okay, so that's F, and I have M1, which is actually 180 minus 2x, and then I have E. Okay, so E is going to be something, and this very E is going to be equal to that one because it's the same E. Okay, so if I was looking for E, I would say 180 minus F minus M1. Okay, and that's basically, I'm just going to say interior angles, okay, of a triangle. Sum of interior angles of a triangle equal to 180. So what is F? F is 90. And what is M1? It's negative 180, and a negative is equal to 2x. So the 180 and the 180 cancel out. I'm left with 2x minus 90. Okay, so that's basically what E is. Okay, so I have 2x minus 90. If I could show that no, I can't. A is 90 minus x. Okay, so what is B then? B, again, according to interior angles of a triangle. So I have 180 minus 90 minus 2x minus 90. Ah gosh, they're cutting grass and it's so noisy. Okay, so 180 minus 90, I have 90 there, minus 2x plus 90. I think I'm gonna pause and then continue later when there's less noise. So B is 180 minus 2x. Okay, so B is actually, if we look at it, B and M are actually similar. So maybe the triangles I should be looking at triangle EBA and triangle EFM, because those look like they're similar. If you think about it, guys, E, we already said it's 2x minus 90. B, we know it's 180 minus 2x. So those are the two triangles I should actually be comparing. Okay, so I can then say B is equal to 180 minus 2x. B is equal to M1. Yes, M1. Okay, I'm gonna soldier through the noise. Please bear with me, guys. I don't want to stop now. Okay, so I then have that E is equal to E. Well, it is what it is. They are equal. I don't know what to say about that. It's the same point or same angle, okay? So yeah, and then I know that M1, or rather let me just say M, is equal to B, okay, which is equal to 180 minus 2x. And I know that A is equal to F, or rather let me just do F, okay? So I have that F is equal to A, which is 90 degrees. Okay, so let's see, with A, okay, so that A, we've already said it somewhere that it's due to the chord being the diameter, and this F is really due to vertically opposite angles. Okay, so now therefore we can say triangle EFM is similar to triangle EAB. Okay, it is important that they are in this order because we said A is equal to E, M is equal to B, and then F is equal to A. You can't jumble it around or else it will just make life a little, not a little, but probably a lot difficult for you. Okay, now that we know all of that, what do we have? Okay, let's go back to the sketch. We have CF. Okay, now we can't really use that at the moment. What do we have? We only have AB, ne? Okay, so according to our similarity rules, we know that EF over EA is equal to FM over AB, which is equal to EM over EB. Okay, what do we know? What do we need? What did the question want? We are looking for AE. Okay, this is AE over here. And what do we have? Okay, CF, we can't use it now, but we have AB. Okay, so I'm gonna look at this, at these two over here, because I don't have any information about EM. Let's have a look at the sketch again. EM, I don't have anything about that. EB, I know it's the diameter. Do I have a radius somewhere? I have only AB and I only have CF. Okay, but let's see how this is gonna turn out, guys. Yo, I feel like I'm falling in a spider's web and I don't have anything. So EF, okay guys, do you see that EF, like we said, because we had a perpendicular bisector, we showed at the beginning that AF is equal to EF. Okay, so okay, because we know that AF is equal to FE, we already proved that. EA, which is the whole length, okay, I know that AF, or EF rather, which is what we have, I know that EF is actually half of EA. Okay, so with that being said, I can then say half of EA over EA is equal to FM over AB, and we already know that AB is 24. Okay, so now I have these ones cancel, so I'm left with the half. I'm gonna take the 24 this side, and now I have FM. Okay, so I know that FM is equal to 12 units. Okay, so what? Let's go and put it in our sketch. So what? I have FM. How does that help me get to what I need? Okay, so FM, which is here, we said it's 12 units. Ne. And What are we looking for, guys? I've forgotten now. We are looking for AE. Okay, AE is there. Okay. AE. So if I have CF and I have FM, do you realize that CM is actually the radius? Okay, so I have the radius here. Okay, and then guys, can you see this triangle? This triangle over here. Now we're going to use proportionality theorem. And you see, oh no, we can't. They never told us that CM, or rather didn't tell us that CD is perpendicular to AB. Okay, never mind. But we know that the radius is CM, and the radius is 6 plus 12, which is 18. So I know that this radius here, we have 18, and we have 18 here. Okay, and we know that we have 24. So yeah guys, it still works. Ooh, the noise. Okay, I'm sorry, I'm gonna finish now. Okay, so we're looking at our triangle here. I'm gonna try to finish. We have E, we have A, and we have B, and we're looking for EA. We know that EB is the diameter. I already told you FM plus CF is the radius. FM is 12, CF is 6. Okay, so our radius is 18. Okay, so if our radius is 18, it means our diameter, which is EB, is equal to 36. So I have 36 here, and I was told that AB is 24. So we're going to use Pythagoras to get AE. Okay, we're almost there. So AE squared is equal to EB squared minus AB squared, which is equal to 36 squared minus 24 squared, all rooted up. That's AE. And we're almost there. Okay. So let me go back to the normal. So we have 36 squared minus 24 squared is 12 root 5 units, which is actually 26,83 units. And we're done. Sorry for the noise, but that is the answer. I'll see you guys. Question 11. Yeah. Hello everyone, and welcome back to MB Tutors. I'm Tolo, and I'll be looking at question 11 with you guys. So we're at the last question. We are finally getting done with maths for 2021. Okay, so let us see what we have here. Okay. So it says in the diagram, chords DE, EF, and DF are drawn in the circle with center O. KFC is a tangent to the circle at F. I hope y'all were not hungry when you saw KFC there. Alright, so yeah. Now it says at the bottom, prove the theorem which states that DFK is equal to E. So what are we trying to prove? We're trying to prove that this angle here is equal to that angle there. And we're basically here trying to come up with the tan chord theorem. We're proving that the tan chord theorem is what's applicable here. Okay, that is our goal. So let us start. How are we going to do that? Okay, so first of all, what I would suggest is that we actually draw a line from the center to the circumference. Actually make it a whole diameter, if you may. Okay, so if I were to use my ruler over here because wow, straight lines are kind of tough. So we have to resort to using rulers. Okay. It doesn't have to be perfect. Okay. So we would draw our construction line there. Okay. So construct. Let me just remove the ruler. So I would say construct the line. I'm gonna call it BF. Okay, so BF. And then you would realize or recognize if I actually closed it up. So we have our diameter there. Let's call the ruler back. I think this side will be quicker. So if we actually constructed that line over there. Okay, let's zoom out a bit. Okay, so if we construct that line over there, you would see that you have a chord DF, you have a chord BF, your diameter, and it subtends the angle there at D, which is 90 degrees, right? Okay, if you also did the same that side, okay, I'm just going to draw a line because it takes time conjuring the ruler. You would also have a 90-degree angle there. So you basically have a cyclic quad. Okay, now what can we see? Let's see what we have. So I would first start by saying, okay, let me just write this side. So you construct line BF, okay, and then you start by saying let DFK, so basically that angle F equal to alpha. Okay, so I have, I'm gonna use green again. I'm gonna have alpha here. Okay, this one there, and let BFD. Okay, so BFD over there, let that be equal to beta. Okay, which is actually, because BFD is a 90-degree angle, you can actually say it is, or rather, you know, when you have a line from the center all the way to the tangent line, this is actually 90 degrees. So you could say that this beta that you have, it's actually 90 minus alpha. Okay, 90 minus alpha. Alrighty. Okay, so we have those set out. We could just say this is beta, or 90 minus alpha, really, whatever rocks your boat. Okay, so if I go up, now we're not going to see the sketch again. Okay, all right, cool. But anyway, yeah, so this over here, the reason why I would say BFD is equal to beta, or it's equal to 90 minus alpha, well, it's basically due to the fact that BF is perpendicular to KFC or KC. Okay, all right, cool. And you'd say that a line from center to chord, since we are giving reasons here. Okay, okay, line from center to, yeah, actually you can just say radius. Yeah, I'm thinking of another thing. So you can say radius is perpendicular to a tangent line. Okay, all right, cool. But now let us start. Guys, you're not gonna see the sketch anymore, but it's fine. I'll keep going up and down. Okay, all right. So now if I look at triangle BFD, ne? Yeah, BFD. I'm just gonna mention the angles, okay? So I have F. Let's start at F. I would say F. I have that as beta, but we know that beta is actually 90 minus alpha. And I have there that D, okay? If you can remember on the sketch, D is actually 90 degrees. Okay, and then B, well, that's basically, we get that by using sum of interior angles, right? So I will say it's 90 minus 90 minus 90 minus alpha. Now I want to put X. Okay, and that will give us, so I have 180 minus 90, that's 90, and 90 minus 90, that is, 0, and a negative will give me a positive. So I have that B is actually equal to alpha. Okay, here I need to say sum of interior angles. Alrighty. And did I say why D? Well, D is 90 because the chord is a diameter. Okay, and that one we have already defined. Okay, so if I look at my sketch then, in triangle BDF, we said that B is actually alpha. Okay, so we're still not there where we are proving that F is equal to E. We need to then see how can we relate all of this to E. Okay, let me just erase this portion here. We already know that it's 90 degrees. Okay, my thing is stuck. Okay, here we go. Okay, let me just extend that line again and try to extend this one. Okay, so now because we have a cyclic chord, if you look at your chord DF, ne, and the angles that DF subtends, so DF subtends B, which is alpha, and DF also subtends E, which will in effect be alpha. Okay, so let's go back and write it. So B, or rather E, is equal to B, which is equal to alpha, and I'm just going to say angles subtended by chord, was it chord DF? Okay, angles subtended by chord DF. So guys, ultimately we can say that DFK is then equal to E. You can see that, right? So therefore DFK is equal to E, because they're all equal to alpha. And this way now we can then say tan chord theorem. So this theorem is really not bad. I think the only thing is your construction. Okay, so the main thing here really is to construct the line, your diameter. Okay, a line from center to your circumference, center to the tangent, and then extend it all the way up so that it becomes a diameter. Once you have that, then it's flowing. Okay, all right, so that is question 11.1. Okay, now let us go to 11.2. Alrighty, so we are on question 11.2. Okay, so it says in the diagram, PK is a tangent to the circle at K. Okay, PK is a tangent to the circle at K. So I am going to put up that tangent line. Okay, I hope you can see. So PK. So we have PK. I'm going to mark it with red. Let's use the ruler so that we have a perfect line, sort of. Okay. There's the tangent. something like that. It's not gonna be perfect, but we can attempt. Okay, so there's the tangent line. All right, great. What else do we have? Chord LS, okay, is produced to P. Okay, so you can see that is L and that is S, and it is produced to P, meaning it's just extended to P. N and M are points on KP. Okay, all right. What? N and M are points on KP and SP respectively, yes, such that MN is parallel to SK. Chords KS and LN intersect at T. So we have T there and you have that intersection. But yeah, we have those parallel lines. So whenever I see parallel lines, I'm thinking to myself, do we have an alternating angle? Okay, I'm not gonna use a ruler for this. It's gonna take up time, but yeah. So do we have an alternating angle such that M2 will be equal to K2? And do we have a corresponding angles? Maybe let me use a different color. Do we have corresponding angles? Okay, you know the corresponding ones do the F. So we have a F here. That's what I look for whenever they say parallel lines. I'm like, okay, where's the F and where's the Z and where's the C, the co-interior ones, but I don't like using co-interior much. Okay, so yeah, and that is it. So let us see, what do they want us to calculate? So they say prove, giving reasons, that K4, okay, K4, this is K4, okay, is equal to NML. So this is N, this is M, and that's L. So basically the angle M, which is going to be M2 and M3. Okay, we need to prove that. All right, so what do we see, guys? Let me just use a different color, maybe yellow. Is there yellow? Yes. So what I see here, if I have a tangent line, I'm going to look for a triangle in the circle. Okay, so I know that if I see a triangle in the circle, I can use the tan chord theorem. And I mean, 11.1, we were already proving the tan chord theorem, so we must apply it somewhere. Okay, so I'm going to look at the triangle KL and S. Okay, so my child wants to play now, and I've been here doing the memo. So let us finish this so that I can go play. So we have this triangle. Yeah, this is the one. So we have a triangle here. Okay, can you see that? And this triangle, guys, it needs to touch the circumference. It can't just be a random triangle. So I can then see what happened. Okay. I can see, according to the tan chord theorem, that actually K4 is equal to S1. Okay, so that is according to the tan chord theorem. And then I can see that S1 is equal to M2 plus M3 because of corresponding angles. So we can write all of that down and we can get our marks. Okay, so 11.2.1. okay, so K4 is actually equal to S1. And why is that? Because of the tan chord theorem. Alrighty, and then S1 is equal to M1 plus M2. Okay, please don't write this. it's wrong. Okay, cool. So yeah, S1 is equal to M1 plus M2 plus M3. Yo. See, now I've covered the numbers, but I can see here that it's actually supposed to be M2 and M3. Let's just erase the whole thing. Okay, M2 plus M3. And why? That is due to corresponding angles. And which lines are actually parallel? We have NM parallel to KS. Alrighty, so therefore we can then conclude that K4, therefore K4 is equal to NML. Okay, so we're done with A. And then we have B. So prove, giving reasons, that KLMN is a cyclic quad. Okay. Let us get maybe a purple that is a bit thick. Okay, so K, where's K? So we have K over here, L, M, N. So we're trying to prove that this is actually a cyclic quad. So let me just highlight it. It's very tough. Okay, so KL. Why is this one doing this? Okay. Maybe I shouldn't try being a perfectionist here. Okay, so will I get there? Yes, I'm there. So that is our cyclic quad, meaning we have a circle that's probably like doing something like this. That is what they mean when they say it's a cyclic quad. They don't mean whatever. They're not saying that KLMN is a cyclic quad of the circle that they've given us already. No, they're just saying that supposing that you have the cyclic quad in another circle, okay, we need to prove that indeed it is a cyclic quad. Okay, so by so doing, I think I'm gonna get rid of this circle. It's a little bit of a distraction over here. So here's the thing. If you want to prove that something is a cyclic quad, you're gonna look at 3 things, okay, and choose one of them and decide for yourself, okay, which one is actually working out. Okay, so what I would go with first is, if I were to have, if I were to have these angles, if I could prove that the angles subtended by the same chord are equal, then cool, we have a cyclic quad. If I can prove that the external angle of a cyclic quad is actually equal to the interior opposite angles, then yeah, cool, we have it. Or if I can prove that the opposite sides of a cyclic quad are actually supplementary meaning that they add up to 180, then cool, we can do that. So looking at our cyclic quad over here, can I use the first rule? Not really, because if I look at the chord KL, it only subtends to S. No, it must subtend to M and subtend to N. So if I can prove, if I can prove that M3 is actually equal to N3, then we're good to go. But where am I gonna start? Okay, if I were to also look at a different chord, maybe KN, M2, as well as L1. Okay, this will be very difficult because they haven't even given us any angle. If at least we had X and we could prove somewhere else that, you know, there's a X again, that would be something. So I don't think I will go with number 1. Okay, even looking at this and the construction, I don't think I would also go for number 3. Again, I would have to have some angle. Okay, and the only angles that we know are actually equal to each other. We know that it's K2 that's equal to M2 because of alternating angles. I know that K4 is equal to S1, which is equal to M1 plus M2. Okay. Okay, K4. K4. Okay, I'm going to go with K4 over here. I'm sure you're like, what's happening? So if we look at K4, okay, and we said that the external angle of a cyclic quad is equal to the interior opposite angle. We know that K4 is equal to M1 plus M2. Okay, and that is the exterior angle that is equal to the interior opposite angle. Okay, because K is actually opposite of M. Okay, yeah. So we can definitely do that. So we could say that K4 again is equal to ML, or we could just say M. We could just say M2 plus M3. Okay, and then we can say that, yeah, exterior angle of cyclic quad. Okay, and that is B. Now let us go to 1.1.2. Oof, my son is busy smashing. Hulk smash. Alright, so prove giving reasons that triangle LKN is similar to triangle KSM. Remember, similar, it's the parallel lines that are vertical. But if it was congruent, they would be like this. They would be horizontal parallel lines. Okay, so prove giving reasons that triangle. So we need to prove that triangle LKN is similar to triangle KSM. Okay, so basically, how would I show or prove that they are similar? I would, if I were given the lengths, I could work with something, but I'm given angles. So I need to essentially prove that L is equal to K, that K is equal to S, and N is equal to M. Okay, angles here. I need to prove that they're actually equal. If I can prove that, then yes, we can then say triangle LKN is similar to triangle KS. Okay, SM. Okay, so let us see. We've already made so many marks. Okay. Okay, let me just erase what I've done there and start again because my thing is a mess now. Okay, let's start again. Okay, my PC is very slow today. I don't know why. What is happening? Okay. Alrighty. So now they're saying prove that triangle LKN. So this is okay, LKN. Okay. It's actually this one over here. Let us make it a bit thicker. Yeah, maybe I need to restart my computer because wow. Okay, so we have triangle LKN. Okay, and then we also have triangle KSM. So KSM. Okay, and remember we already proved that KLMN is a cyclic quad. So yeah, just really bear that in mind. Okay, so I said, what are we going to look at exactly? We're going to say, let's see if L is equal to K. So we have K over here and we have L over there. Is there a way of proving that K is equal to L? Let us see. I can't see anything at the moment. Not at the moment. Let's go to the next one. We'll come back to K and L. Okay. All right. So yeah. No, what was I doing? Yeah, L is equal to K. Yes, can we see anything? L? Anything? K? Maybe not now. All right, let's go to the next. K is equal to S. Okay, so okay, so the K. So K meaning K1, K2, K3 is equal to S2. Okay. Geez, why is this not looking up for me? Okay. Okay, I said K is equal to S. Okay, let's see. How can the two be equal? So I know that, okay, I know that K4 is equal to S1, ne? We did it by using the 10-chord theorem. Okay, so if K4 is equal to S1, and we have that K1 plus K2 plus K3 plus K4 on a straight line, and we also have that S2 is on a straight line with S1, then they have to be equal. I don't know if you get me. So I have my blue pen over here. So K1, okay, plus K2 plus K3, okay, which I take them really as K. Let me just reduce the thickness. Which I really take them as, oh, you probably can't see what I'm writing. Sorry. Okay, this laptop is tired. Or maybe the mouse doesn't want to work anymore. I don't know what's happening. Okay, so K1, K2, K3, that is actually K. Okay, the K that we're looking, the second one here. So that's K. And we are saying that K has to be equal to S. Okay, for KSM, which is basically S2. Okay, so now I'm saying to you guys that K and K4 are actually K plus K4 must be equal to 180 because of angles on a straight line. Okay, angles on straight line. Okay, and then I'm saying to you that S1 plus S2 also are equal to 180. The same reasons, angles on a straight line. So if K4 is equal to S1, then it means that K is actually equal to S2. Okay, are you with me there? Okay, let's write that down. So we've proved one of them. So K is equal, to S. Okay, and that reasoning there, I'm just gonna say A, B, C. So now we're looking at B. So I said K plus K4 is equal to 180 angles on straight line. Okay, and then I'm saying S1 plus S2 are equal to 180, same reason. Therefore, if K4 is actually equal to S1, it then means that K is equal to S2. Okay, so we are done with this one. Now, can we show that actually M and N are equal? Let's see. So I'm looking at M3. Okay, let's choose a different color. Go for green. So looking at N3 equal to M3. Okay, can that happen? I think it can. If you look at your chord KL, yes, KL actually subtends M3. Okay, and KL also subtends N3. All right, so yes, that can happen. So N is equal to M. Okay, so N is equal to M because same chord. Okay, yeah, same chord, and that's cyclic quad. N K L M N, cyclic quad, because we already proved that it is a cyclic quad. So we go back to LK. Well, at this point, if you already proved that two angles in a triangle are equal, then the last one automatically becomes equal because of sum of angles in a triangle. But guys, there must be a reason. I'm still there. So if I have a look at L, let's use a black pen. I want to prove it. So if I have a look at L, okay, and if I have a look at M2, these two are actually equal. Okay, so if I say L1 is actually equal to M2, why? Because they're from the same chord KN. Ne? So if those two are equal, M2 is actually, if I take the Z, M2 is actually equal to K2. Okay, M2 is equal to K2 because of alternating angles. Okay, where MN is parallel to KS. Okay, and then we also see, so if L is equal to M and M is equal to K, then L is equal to K. Yes, yeah. So this is how you could prove that L is actually equal to K. Ne? Yeah. Therefore, but like I said, if you've already proven two of them and one of them is remaining, you could just say as your reasoning, sum of interior angles. Yeah, sum of angles. Okay, and then so at the end, therefore triangle LKN is similar to triangle KSM, we're done proving it. All right, guys, 11.2.3. Yes, I also want to finish like you want to finish. I'm sure you're tired at this point. Okay, now it says if LK is 12 units, so LK is 12 and 3 KN is actually 4 SM, determine the length of KS. Okay, so what is KS? All right, let's go back to the sketch. Let me erase everything. Okay, so we have LK, that's 12 units. Alrighty. Okay, LK is 12. Okay, let us put that in. LK is 12 units, and then KN. So this is KN over here. I'm just gonna circle. KN is actually 4 times SM. Determine the length of KS. So I'm looking for this length over here. Alrighty, where will I even begin? Well, we have already proved that triangle LKN is similar to triangle KSM. So let's go see what we can do with that information. That is what we actually need. So I have that LK over KS is equal to KN over SM, which is equal to LN over KM. Okay, so we are looking for KS, right? This is what we are looking for. We have LK. They already gave us, okay, so this is what we're going to use here. Okay, so LK is 12. KS is what we are looking for. KN is actually, if I just get KN by itself, it's 4 over 3 SM. So I have 4 over 3 SM over SM. Okay, so this is nice and quick. It's going by quite quickly. So we can definitely cancel the SMs, okay? And then we have 4 over 3 KS. Okay, so I have 4 over 3 KS. Once these SMs cancel, this KS can go over to the right, but I'm leaving it here on the left. And then we have that equal to 12. Okay, so therefore KS is 12 times 3 over 4. And that will be 9, because 12 divided by 4 is 3. 3 times 3 is 9. So KS is 9 units. Okay, this was nice and fast. Let's see if the last question of this whole paper will be as quick as well. So 11.2.4. If it is further given that NL is 16 units, LS is 13 units, and KN is 8 units. Determine with reasons the length of LT. Okay, that is a whole load of info there. So where are these things that they're telling us about? Okay, it is further, if it is further given. So we know that KS, that was 9, right? KS, we've determined it's 9 units. KL is 12 units. KS, okay. And then what else do we know? We know that NL, oh, this long one, okay. NL is going to be 16 units. Okay, so I can't really, okay, I can, I suppose. So that is 16 units. And then LS, where's L? Okay, LS, so over here, we have 13 units. And then KN, oh, KN is 8 units. So 8 is equal to 4 times SM. So we can actually have SM, right? SM is actually equal to 8 over 4, ne? Which is 2 units. But yeah, because previously they said that 3 KN. Ooh, okay, no, never mind. Nope, doesn't work that way. Never mind. 3 KN. So 8 KN is 8 units. Sorry, KN is 8 units. Okay, so 3 KN is equal to 4 SM. Okay, and what else did they tell us? KN is 8 units. So 3 times 8, that is 24. 4 SM. So basically SM is 24 divided by 4, which is 6. So this value here is 6. And they're looking for LT. This is L, okay, and that is T. Okay guys, I don't know if you realize this, but we actually are going to use the proportionality theorem because I see a triangle with the base having a parallel line to it. Okay, so I'm just gonna redraw it and then put in all these values, okay, that I have been writing in. Okay, let's do this and let's finish off this question. Okay, so like I said, we have a triangle. Oh, the heights. What is this thing doing to me? I think this laptop is tired, and so am I. Okay, it's not a right angle triangle, ne? Okay, so we have L there, we have T, we have N, and M, and S. Okay, so we have been told, so these two are parallel. Okay, we know that NL is 16 units, so this whole length here is 16. We know that LS is 13. Okay, we know that KN is 8 units, but KN actually helped us to get SM, and we calculated that SM is 6 units. Okay, and then we're looking for LT, so this should work out quite well. All right, so remember they said 3 KN is equal to 4 SM. Sorry, I'm gonna rewrite it again. This is 24, that's 4, therefore SM is equal to 6 units. Okay, so because of the proportionality theorem, we can then say that Ln over Lt is actually equal to Lm over Ls. Okay, and then we can say proportionality theorem, okay, where we have that Ts is parallel to Nm. Okay, and then we can further say that Ln is 16, that was given to us. Lt is what we are looking for. Lm is going to be Ls plus Sm. Okay, so that's going to be 19. And then Ls, that's 13. All right, so in order for us to get Lt, finally, okay, some mathematics, gymnastics. Yes, I said it. I took it from my husband who took it from Lungisinkosi. So yeah. So now I can take LT to the right, and I can take 19 over 13 to the left. So it's going to be 16 divided by 19 over 13, which is actually the same as saying 16 times 13 over 19. And if we take out our calculator, we're going to see 16 times 13 over 19. And that is 10,95 units. And guys, we are done. It is done. It is finished. Okay. Thank you, Department of Education. Yeah, we are done. I really hope you'll take this time to reflect. If you remember your answers, you know where you went wrong, you know what was actually tough for you, what was difficult for you, and you'll take this time just to reflect, look at where you went wrong, make sure that you're actually getting it, especially if next year you'll be using maths going forward, and especially if next year you feel like you didn't do that well, so you want to upgrade. This will help a lot. And like I always say, please share this with someone who needs it as well. Those are going to upgrade, as well as the grade 11s that will be in matric. Thank you. Bye.